artificiality compared to the real world, which is colored in blue, and the human's artificial constructs, which are blank canvas white. Green was the color of early monochrome computer monitors, and starting the film already in this green-coated matrix makes us feel like the world of the viewer may also be simulated. Opening with green text is one of many things the Wachowskis pulled from the 1995 anime which also explores the existentialist implications of a future when human brains can be hacked and consciousnesses can be detached from the body. The Wachowskis pitched The Matrix, showing producers at Warner Brothers Ghost in the Shell, and many things from the character of Major's similarity to Trinity, the idea of plugs in the head, the visual of cracking concrete upon landing, and all the shootouts just evoke the great animation of that film. This reigning Matrix code is actually a typeface made up of mirror images of hat-whipped Kana characters, Western letters, and numerals. Designer Simon Whiteley reportedly based this code on his wife's sushi recipes. Yet this idea of mirror images recur throughout this film, and so does this imagery of raining code. The window wipers on the skyscraper, the rain gushing down the Adams Street Bridge, and on the back windshield of that car. These are literal prison bars trapping these humans inside. And we open on this code because this is an opening point of view shot from the eyes of the Matrix, a trace program listening in on Cypher's call with Trinity.
You weren't supposed to relieve me.
I know, but I felt like taking a shift.
This opening exchange already tells us that Cypher is annoyed that Trinity dropped in on him because these late-night hacks are when he is able to feed intel to the agents.
The informant is real.
And so Cypher teases Trinity.
You like him, don't you? You like watching him.
Cypher teases Trinity's voyeurism, knowing that the real voyeur is the big brother also listening in on this call. The phone number is 312-555-0690. 312, area code for Chicago, the Wachowskis' hometown. They shot this movie in Sydney, Australia, but all the street names like Wells and Lake, these are all Chicago references. Neo's Metacortex boss is a picture of Chicago in his office. 555 because it's a fake movie number, and 555 numbers don't exist in the composer Don Davis's horns. Subtly coated with existentialist philosophy, Christian theology, themes of gender identity, and conspiratorial details that continue to free our minds to this day. We must re-enter the Matrix because even on this latest hack, I discovered dozens of new details, and I realized this film prophetically trapped us within a matrix of misinformation, lies that we prefer to the truth, because red meat tastes so much better than tasty wheat, and ignorance is bliss. We actually open with composer Don Davis's horns. There's already so much meaning hidden in this music. These two opening chords are mirrored versions of each other. E minor, C major. E minor is B, down 4 semitones to G, and then down 3 semitones to E, whereas C major is C, then up 4 semitones to E, and then up 3 semitones to G. So E minor is the sorrowful hell of the Matrix, whereas C major is the triumphant freedom of the real world that Neo flies up toward in the final shot. Davis plays E minor with a whole horn section, the imprisoned masses, while C major is a smaller number of trumpets, the few free. Two parts mirroring each other, and each successive Matrix film will actually ascend to show mankind's gradual ascent toward freedom. The first in E minor, Matrix Reloaded in F sharp minor, and then Matrix Revolutions a half step up to G minor. The film's opening title cards and the reigning numerals are all the color green, as a green tint colors every shot that takes place inside of the Matrix to convey its artificiality compared to the real world, which is colored in blue, and the human's artificial constructs, which are a blank canvas white. Green was the color of early monochrome computer monitors, and starting the film already in this green-coated Matrix makes us feel like the world of the viewer may also be simulated. Opening with green text is one of many things the Wachowskis pulled from the 1995 anime Ghost in the Shell, which also explores the existentialist implications of a future when human brains can be hacked and consciousness can be detached from the body. The Wachowskis pitched The Matrix, showing producers at Warner Brothers Ghost in the Shell, and many things from the character of Major's similarity to Trinity, the idea of plugs in the head, the visual of cracking concrete upon landing, and all the shootouts just evoke the great animation of that film. This reigning Matrix code is actually a typeface made up of mirror images of hat-whipped Kana characters, Western letters, and numerals. Designer Simon Whiteley reportedly based this code on his wife's sushi recipes. Yet this idea of mirror images recur throughout this film, and And so does this imagery of raining code. The window wipers on the skyscraper, the rain gushing down the Adams Street Bridge, and on the back windshield of that car. These are literal prison bars trapping these humans inside. And we open on this code because this is an opening point of view shot from the eyes of the Matrix, a trace program listening in on Cypher's call with Trinity.
You weren't supposed to relieve me.
I know, but I felt like taking a shift.
This opening exchange already tells us that Cypher is annoyed that Trinity dropped in on him because these late night hacks are when he is able to feed intel to the agents.
The informant is real.
And so Cypher teases Trinity.
You like him, don't you?
Code site smarter, with fewer plugins and more control on Wix Studio. Develop locally on your preferred platform or online in our VS Code-based Wix IDE. Either way, you're working side by side with designers, creating the...
You like watching him?
Cypher teases Trinity's voyeurism, knowing that the real voyeur is the big brother also listening in on this call. The phone number is 312-555-0690. 312, area code for Chicago, the Wachowskis' hometown. They shot this movie in Sydney, Australia, but all the street names like Wells and Lake, these are all Chicago references. Neo's Metacortex boss is a picture of Chicago in his office. 555 because it's a fake movie number, and 555 numbers don't exist in the real world, and 0690 because this movie's also horny as f***. And we pushed in on the 0 of the number to reveal it as columns and columns of sophisticated analog machinery zapping like the stacks of human farm pods, suggesting that even something as simple as a 0 masks an array of simulated clockwork. And we arrive from this at the police flashlight, representing the Matrix's Eye of Sauron as they close in on the ghost in their machine, Trinity. Her name, our first of many nods to Christian theology, the Holy Trinity, and her room number is 303, which is a triple of 101. Neo's apartment number 303 is also the HTTP status code, meaning the requested resources available at another location. This is the same room Neo is directed to in the final chase and runs into Agent Smith. This Puerto the City hotel is the same one recognized this code on his wife's sushi recipes. Yet this idea of mirror images recur throughout this film. And so does this imagery of raining code. The window wipers on the skyscraper, the rain gushing down the Adams Street Bridge, and on the back windshield of that car. These are literal prison bars trapping these humans inside. And we open on this code because this is an opening point of view shot from the eyes of the Matrix, a trace program listening in on Cypher's call with Trinity.
You weren't supposed to relieve me.
I know, but I felt like taking a shift.
This opening exchange already tells us that Cypher is annoyed that Trinity dropped in on him because these late night hacks are when he is able to feed intel to the agents.
The informant is real.
And so Cypher teases Trinity.
You like him, don't you? You like watching him?
Cypher teases Trinity's voyeurism, knowing that the real voyeur is the big brother also listening in on this call. The phone number is 312-555-0690. 312, area code for Chicago, the Wachowskis' hometown. They shot this movie in Sydney, Australia, but all the street names like Wells and Lake, these are all Chicago references. Neo's Metacortex boss is a picture of Chicago in his office. 555 because it's a fake movie number, and 555 numbers don't exist in the real world. And 0690 because this movie's also horny as f***. And we pushed in on the 0 of the number to reveal it as columns and columns of sophisticated analog machinery zapping like the stacks of human farm pods, suggesting that even something as simple as a 0 masks an array of simulated clockwork. And we arrive from this at the police flashlight, representing the Matrix's Eye of Sauron as they close in on the ghost in their machine, Trinity. Her name, our first of many nods to Christian theology, the Holy Trinity, and her room number is 303, which is a triple of 101. Neo's apartment number 303 is also the HTTP status code, meaning the requested resources available at another location. This is the same room Neo is directed to in the final chase and runs into Agent Smith. This Puerto the City hotel is the same one recognized by Smith when he looks up at it during that chase, remembering it from this opening scene, which is how he's able to cut Neo off. In the exteriors of this block, there are signs for Kung Fu, and up on the rooftop, an actively smoking sign for guns and ammo, foreshadowing this kind of action we should brace ourselves for in this movie. There's a great split focus shot of Trinity in focus in the foreground and the cop in focus in the background, framed in the fold of her arm. We also see this with Agent Smith looking up at the fire escape. It's just a way of showing heightened sentience of beings aware of the simulation, but not as cool as the bullet. Bullet time! A visual technique created by VFX supervisor John Gaeta, who won an Oscar for this film. Gaeta credited Akira director Otomo Katsuhiro and Michel Gondry for this look, but he used an array of still cameras pointed at a singular subject, timing each of these cameras to go off right after the other, and combining these still images with tracking motion cameras, reaching a frame frequency upwards of 12,000 frames per second. Gaeta wanted to create, quote, a visual analogy for privileged moments of consciousness within the Matrix, as these characters are able to bend the laws of gravity and have a 360-degree awareness of the simulated reality around them. But these dazzling visuals were really the marriage of revolutionary camera work and VFX, but also straining wire-assisted stunts, choreographed by Hong Kong action cinema director Yuan Wu Ping. This way, the actor is always able to maintain intense focus in the stunt to convey the camera movement as their own astral perspective spinning around them. After she beats all the cops, you'll notice one Trinity's laptops create our images of Neo, so she knows that the Matrix will now be targeting him and has to make her move tonight. Choi and DeJour, with the Right Rabbit tattoo. These rooftop sets were previously used in the film Dark City, which is another story about humanity being kept in an intricately constructed simulation. The costumer Kim Barrett designed Trinity's black leather to look mercury-like and oil slick to reflect light in an interesting way, so that she literally looks like she's slipping in and out of this code. Kim's name is actually scratched in graffiti on the elevator later, and when Trinity torpedoes through the window, I like how she curls her fingers into fists so that she doesn't break her fingers on it in class.
All right. See, Miss Jewel is here. Just that link for the Matrix is, I put it in the chat. So at your leisure, go ahead and look at it. Very interesting. Breaks down the movie. And whenever Miss Jewel pops it in, we are ready for her. Yay, yay.
Hey, James, did they already have their break?
Yes, ma'am. They're good to go.
All right. All right, so actually what we're going to be doing is we're going to continue with the mock interviews. So essentially what I'll do is I'm going to just go ahead into another breakout room, and I'll just be pulling you guys in for your mock interviews. And yeah, hopefully we get done with these soon, and we'll be good to go. Just see here. Bear with me. Okay, let me just see. Breakout room. Okay, I'm going to go into room 1, and let me just see who's here today. All right, so Olivia, you already did yours. Actually, first one up will be Elaine. So Elaine, I'm going to pull you into breakout room 1, and we're good to go. Actually, okay, yes, that's correct.
And for those of you guys that are currently here watching, from time to time, I may be in and out of interviews. So if there is the video on but there's no sound, you can leave your comments. I also put a poll in the chat, so you can respond to that as well. So I can further interact you based on the inputs that you put. So as the channel grow and you put inputs into the channel and the polls that I put in any of the live, you will see all those implementation go into the channel. So I put a poll into the chat. If you'd like to go ahead and respond to that so I can know what is it that you guys like to see and are looking for.
This is also measured as an amount of time, and again, we would like that RPO to be as close to zero as possible. RPO represents how much time we lost when that outage occurred. We have a certain amount of data that goes back in time that was not stored, it was not backed up, and when that outage occurs, we would lose all of that data. Generally, this is a value that you've already determined. You would make this determination based on what resources you have to recover this data and the types of backups that you may be doing throughout the day. And this RPO may be different depending on the type of business you're in. For example, if your organization handles banking transactions or you manage patient information, you want to be sure that you don't lose a lot of that data. So you may put methods in place to be sure that you are only losing a small amount of time when an outage occurs. This might be, for example, a very short time frame that would be less than an hour. But maybe your organization works with other types of data that don't require such a short RPO. For example, any updates to your website or updates to internal documents may only be backed up every hour or 2 hours. So there would be a longer RPO associated with that type of data. If we were to look at both of these values on a timeline, you can see that as time is going by, we have a certain data recovery point. Maybe this is where data is backed up. Maybe we are replicating data to a different site, but we are making a copy of that data or storing that data in a way that we could recover later. Sometime after that point, we would have an outage, and the time that we have between that outage and the back in time period to that data recovery point would be the recovery point objective, or the RPO. So now we're focused on resolving this outage. We need to resolve the issue with the servers, deploy new servers in a different location, move the data center to a backup site, or do whatever we need to do to recover from this disaster. And then finally, when our services are back online, we can measure that time frame between the outage and the online time frame as a recovery time objective, or an RTO.
Their pasts lingered, their legs still heavy. Does misfortune hold them back?
When these issues occur, it's useful to know how long it's going to be to resolve this problem. And it might also be good to be able to predict when problems might occur. We can provide estimates for both of those values by using MTTR and MTBF. MTTR is the mean time to repair. That is, on average, how long it will take to resolve the issue associated with that particular problem. Maybe it's a router that's failed and we need to replace that router to get back up and running. The average time frame for replacing that router would be our mean time to repair. A better plan might be to use systems that are designed to stay up and running as long as possible. So we would need to put in equipment that would have a very long mean time between failures, or MTBF. The MTBF is generally based on a number of criteria, but it's presented as a single time frame. For example, if you purchase a firewall, that firewall's MTBF may be 20 years before you would expect that device to fail. So you can then make disaster recovery plans around that time frame. If you see that your firewall has an MTBF of 20 years, you might only need one additional backup unit instead of purchasing multiples, because you know that device is going to last, on average, a relatively long period of time. If we're dealing with a significant disaster, we may need to move out of our existing data center and into a temporary facility. But making that change is often not a simple process. There are a lot of different moving parts and things that have to happen to move your entire data center from one location to another. And then once you've moved to that other location, you then have to move everything back once you're up and running again. We refer to this moving of one location to another as site resiliency. One example of this site resiliency may be the process you go through to prepare that disaster recovery site. You need to make sure you have power, you may need to bring in additional hardware and have it staged prior to a disaster, and you may want to have data that's transferred over. Once that disaster occurs, you will have a process where you move from your primary location to this backup facility. You would then work from this backup facility until the problem is resolved at the main location. This might take an hour, it might take a day, or it could take months depending on the problem that's occurred. Every disaster will be different, and we have to think about that time frame when we're preparing the alternate site. And of course, when we are ready to move back to the original data center, there is another process where we would take all of our assets and our data and move it back to the original location. If you're going to be using a separate disaster recovery site, there are a number of different ways to set up this particular facility. One is with a cold site. This is effectively an empty building. None of our equipment is in this building, and none of our data currently resides at this location. We need to grab backup tapes or equipment that has our data and move it to this location to be able to perform disaster recovery. We also don't have any people at this location, so we may need to transport people from one location to another so that they can work at this physical site. This obviously means we have a lot of work to do if we call a disaster, but it also means that this is a relatively inexpensive place to use as a backup location. If you needed to have a disaster site where you could very easily move in and be up and running, you may want to consider a hot site. A hot site is an exact replica of your data center, or as exact as you can make it for something that's a disaster recovery location. This means it has the same hardware that you are currently using in your existing data center. And it's very common that when you're purchasing new equipment for a data center, that you also purchase additional units for your hot site. And of course, not only do we need equipment at this hot site, we also need our applications and our data. It's very common to have replication systems or ongoing backups so that the data at your hot site is as close to the data that you're running at your primary location. And by putting all of this in place at the hot site, we can then move relatively quickly from our primary data center to this disaster recovery location. And since we don't have to install any hardware, install any applications, or recover data from backups, we can be up and running relatively quickly. A warm site would be somewhere in the middle between a cold site and a hot site. This is a site that might have some level of infrastructure, that might have power and racks, and in some cases might even have additional hardware that you could use. And so all you would need to do is show up with your data, recover from your backup tapes, and you would be up and running. There's different levels of service that you can use for a warm site, so you can decide just how much hardware or how much data you would like to have staged at that location. It's always a good idea to practice and run through tests so you know exactly what to do should a disaster occur. But that process of going through a full-blown disaster recovery test can be relatively costly. This will take people out of their normal jobs and perhaps in some cases send them to a separate location to be able to perform the actual disaster recovery test. Instead of going through a full-scale test, it might be useful to have everyone sit around a conference table and go through the process that they would follow if a disaster was called. This would allow all of the different departments in IT and all of the management of the company to step through simulated problems and describe what they would do in those particular situations. This means we don't have to go through the physical process of going to get our backups and taking them to this remote location, but it does require that everyone step through the process and see if all the logistics are in place to get that data from one location to another. Since we're all sitting around a conference room table to be able to describe the process that we would follow, we refer to this as a tabletop exercise. This is a meeting that you can go through in about a day or two, and all the key players will be participating and stepping through the process that they will follow if a disaster is called. There are some organizations, though, that go through a full-blown disaster recovery site either once a year or multiple times a year So it's always good to go through these validation tests. That way, if a disaster occurs, everyone in the organization will know exactly what to do. When you're running through these validation tests, you're obviously not actually moving from a production environment into your disaster environment, but you are going through exactly the same process. Usually these validation tests will follow a particular scenario. For example, let's say a fire was to destroy the building where your primary data center existed. There would be a series of processes and steps to be able to move everything to the disaster recovery site. But what if the scenario was different, where everyone in your geographic area around that data center had to be evacuated? In that situation, there might be a different set of steps to be able to get all of your applications and all of your data from your primary location to that backup site. Once everyone steps through this scenario and goes through the entire, you can document what worked and the things that need to be fixed for later. This allows ongoing improvement so that we know exactly how to be more efficient when moving everyone to a disaster recovery site.
Welcome back to the strongest connection.
With most options, I've been waiting for something special, but it's been buffering. But Underline, our connection is strong and ultra fast. This is gonna last.
Underline, local gigabit internet that loves you back. Life insurance, priced for you and your budget, with help from your State Farm agent.
Contact State Farm agent Larry Lucero today.
Like a good neighbor, State Farm is there. Get a quote today.
Maintaining uptime and availability on the network can be a challenge, and in this video, we'll look at different methods for providing that network redundancy. One of the most common forms of network redundancy is active-passive. This is where you would have two separate pieces of equipment, but only one of them is active or running at any particular time. These two devices are constantly communicating between each other, giving updates on their status. And if the primary device fails, the secondary device takes over as the primary device on the network. This means the configuration between these two devices needs to be identical, and if you make a change to the configuration on the primary device, it needs to copy that configuration to the secondary device. You also need to make sure that any real-time information is updated between both devices. So if there is a session table or a routing table, all of that information also needs to be copied and maintained on the secondary device. That way, if the secondary device does become active, it has exactly the same configuration as the primary device did. Visually, this is how it would look on a network map. You have an internet provider, say our network connection out to the rest of the world. There are two firewalls in this configuration, and behind the firewall is a router, a switch, and a web server. In this case, these two firewalls are running as an active-passive configuration. One of the firewalls is active, and the other firewall is in a standby or passive mode. When traffic is sent through the network, that traffic passes through the active firewall to the web server that's on the other side. But let's say that primary firewall had a problem. Perhaps the power supply failed, maybe the software crashed, but something within that device has caused it to go offline. This means that we now have no available firewalls on our network. But of course, our passive firewall has been in constant communication with that active firewall and recognizes that it's no longer on the network. So the passive firewall now makes itself into an active firewall, and it becomes the primary device on the network. So now any future communication on the network uses this new firewall to be able to complete that communications path. You might be looking at that network design and think, you've purchased two firewalls, both of them are plugged in and they're powered on at the same time. Why don't we use both of those firewalls simultaneously and take advantage of all of that extra computing power? Having both of those devices operating simultaneously is referred to as an active-active configuration. However, simply turning on both devices and running traffic through both of them is not always a simple task. There's usually a bit more engineering required to make sure that you can turn on both of the devices and use both of them simultaneously. For example, you might have data flowing through the network in different directions. Maybe one part of the conversation goes through one device and the return part of the conversation goes through a different device. You need to have some type of mechanism that keeps track of all of these different data flows and what device they're flowing through. This often requires a good bit of design work and understanding of exactly where the traffic flows are in the network, how the routing is configured, where the switches are located, and how you would expect traffic to flow on a normal basis. And as you would expect, with an active-active configuration where both firewalls are operating simultaneously, you can send traffic through the network, and one traffic flow may go through one of the existing active firewalls, and a secondary traffic flow may go through the alternate or secondary active firewall. If one of the firewalls was to fail, you don't have to worry about failing over to a secondary because both firewalls are already active. The other firewall that's remaining will continue to handle the load, and traffic will continue to flow normally through that network.
This is a team feeling zen. And these are the Dell PowerEdge servers that make them feel that way. They take care of themselves. So the team can spend less time stressing and more time growing their business.
At Sprouts, our wide open layout invites you in. With healthy around every corner and tasty on every shelf. This is that Sprouts feeling.
On our modern networks, we've become so accustomed to simply turning on our systems, and we're able to communicate with other devices on our local network or browse the internet. But it wasn't always this easy. We used to manually configure all of our IPv4 configuration settings, the IP address, the subnet mask, the DNS settings, and everything else associated with TCP/IP was all configured manually on every device. In order to scale this process, we created a new protocol that would do all of this for us automatically. This was called the Bootstrap protocol, or BootP. But BootP didn't configure everything automatically, and there were a number of enhancements that we would like to make to the protocol. For example, if someone left the network, it would be nice if this protocol recognized that that IP address was now available. So we created a newer version of BootP called DHCP, or the Dynamic Host Configuration Protocol. DHCP is the protocol we use today to provide these automatic address configurations for all of the devices on our network. The process for defining these IP addresses automatically follows 4 different steps that we're going to call DORA, D-O-R-A. The D stands for Discover, where there is a discovery process where you find the DHCP servers that are on your network. The next step is the offer phase, where we get an offer from a DHCP server. The third step is the request process, where we request one of the offered IP addresses. And then lastly, we have the acknowledgement phase, where we tell the DHCP server that we have received that configuration and are using that particular IP address. Let's step through all 4 of those phases from the perspective of this network diagram. On this diagram, we have Sam that has just connected her laptop to the network, and she needs to receive an IP address. On her local subnet, you can see there is a single DHCP server, and there are other devices on this network that we're simply not showing in this particular diagram. There's also a router, and this router is connected across a wide area network to another router where there's a separate switch and another workstation that is owned by Jack. Let's focus on the process that Sam is going to use to obtain an IP address. This first step is the Discover step, and in this step, Sam's workstation is going to send a DHCP Discover packet. It's going to be sent from an IP address of 0.0.0.0 because Sam's workstation currently does not have an IP address. And this packet is going to be sent in an IP broadcast, which means it's going to be sent to 255.255.255.255. This is sent as a broadcast so that every device on the subnet will see this DHCP request, and if the device happens to be one or more DHCP servers, those devices will be able to respond back. You'll also notice that this request is sent using UDP port 68 on Sam's workstation, and the broadcast is sent to UDP port 67. This packet is sent from Sam's laptop, and because it's a broadcast, it's sent to all devices on this local subnet. The DHCP server will see that broadcast and it will send a DHCP offer, which is step 2 of the DHCP process. This DHCP server has an IP address of 10.10.10.99 and it will send this with a source port number of UDP port 67. Notice that the DHCP server is going to send this as a broadcast. Send it to 255.255.255.255, and it's going to send this to a destination port number of UDP 68. This is obviously being sent as a broadcast because Sam's workstation currently does not have an IP address. The only way that Sam's device would see this packet is if it's sent to all devices on the subnet. This DHCP offer will be sent from the DHCP server and broadcast to all devices on the subnet. If there were multiple DHCP servers on this network, Sam could potentially receive more than one offer from a DHCP server. So in step 3, Sam's device is going to choose one of those offers and send a DHCP request to that particular request. Is obviously coming from 0.0.0.0 because Sam still does not have an IP address. It is sourced from UDP port 68, and the destination is going to be 255.255.255.255, another all ones broadcast, and it's being sent to a destination port number of UDP port 67. This traffic flow is very similar to that first Discover traffic flow, where all of the packets are broadcast to all devices on this local subnet. And the last step is step 4, or the acknowledgement. This is sent from the DHCP server back to this device, acknowledging that it has received that request. The acknowledgement is sent from the DHCP server, in this case 10.10.10.99, with a source port number of UDP port 67. And again, it is sent to a broadcast address, 255.255.255.255, with a destination port number of UDP port 68. And again, this will go to all devices on the subnet, but obviously the only person waiting for that acknowledgement would be Sam's device. Now that Sam's laptop has received the acknowledgement from the DHCP server, it can now configure all of the IP settings automatically for Sam's laptop. As you may have noticed from that network map and the different phases that we went through with DHCP, there is a significant limitation associated with the DHCP process, and that is the broadcast that is being sent by the different devices. Broadcasts, of course, are only transmitted to your local subnet, and none of those broadcast frames will traverse a router. This becomes a challenge for an enterprise network where you'd like to have redundant DHCP servers and ideally have those DHCP servers distributed across different parts of the network. Fortunately, there is a way to implement DHCP in this environment by using some additional features of your router. We also might want to centralize these DHCP servers instead of having separate individual DHCP servers that are scattered across every remote site that we might have.
All right, class, I am back. Actually, we only got 2 minutes left, so what I'll say is, next class I come in, I'm going to continue to complete the mock interviews. We don't have another presentation or things like that for a little bit, but we'll be completing the mock interviews. Please, in the meantime, leading up to this, me completing the mock interviews, make sure that your LinkedIn profiles are completed, right? You guys all have that LinkedIn checklist. Make sure that those are completed so that once we complete the mock interviews, I can take a look at your LinkedIn page. It should be at that time all good to go, and I can just give you insights on minor changes that you can make so that your profile will be in a good position for recruiters to find you and for you to use it to apply to positions online. Okay? All right, thank you all. Hope you have a good rest of your day. See you next week.
Broadcast is received by the router configured with DHCP relay.
See you later, Michelle.
Configuration and realize there is a DHCP server at 10.10.10.99.
All right.
Relay that information.
Top of the hour. Let's go ahead and take a break. See you at 10 after.
To the IP address of the router, in this case 10.10.30.1, and it changes the destination address to the IP address of the DHCP server. It effectively takes what was a broadcast and turns it into a unicast communication. This packet can now be sent across the network to a DHCP server that's located on a different subnet. The offer process works exactly the same, but in reverse. The offer leaves the DHCP server and is directed with unicast to the router's IP address at 10.10.30.1. At this point, the relay modifies this back to a broadcast and is sent to the local subnet with an all-ones broadcast. This process repeats for the last two phases of the DHCP process, and that allows Jack's workstation to receive an IP address even though the DHCP server may be on a completely different IP subnet.
My kids can't hide anything from me. I'm home. Especially when they've been using toilet paper that doesn't hold up. Charmin Ultra Strong has a diamond weave texture that's more durable. And it cleans better, so you can use less. Enjoy the go with Charmin.
I'm being told this is legal evil from Liberty Mutual. Help save you hundreds by customizing your car insurance. And his private dog is the gentleman under the security guard.
Only paying for what you need.
Liberty, 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 liberty.
In our previous video, we looked at the process of DHCP from the client's perspective, but obviously there are a number of configurations that have to be made to the DHCP server itself. So in this video, we'll look at some of those DHCP configuration settings. When a device requests a DHCP address, the DHCP server refers to a list or pool of addresses that are defined within a DHCP scope. This scope commonly includes the IP address range that will be handed out to the different devices on the network, as well as any addresses that should be excluded from the DHCP pool. You also have your subnet mask as part of this scope. There are also lease durations, so you know exactly how long these IP addresses will be available on that device. And there's other options that you might include, such as the DNS servers that need to be configured, default gateways, and other additional optional settings, such as voice over IP server IP addresses. There are usually a pool of IP addresses created on a per subnet basis, and each scope usually is responsible for providing that particular subnet's IP addresses. Usually this is a contiguous pool, so you can tell the DHCP server to assign addresses 1 through 100 on this particular subnet. And then if you want to create exceptions to that, you can add them to the scope as well. Here's what this looks like on the server manager on Windows Server. This is part of the DHCP server settings, and this particular DHCP server handles the network sg1.sgc.local. You can see there is a single scope available on this network. Its scope is 165.245.44.0, and within that scope you have a pool of IP addresses that would be handed out, the address leases, any reservations in this IP address range. Reservations are for devices that will always receive the same IP address each time it is requested, and then scope options that you might include along with others on this scope. So if you need to make changes to the IP address pool or modify any of the DNS configurations or anything else associated with DHCP, you do that all from this DHCP settings inside of this scope on the server. This process happens automatically for the end stations. They make a request to the DHCP server, and the server goes through the pool of addresses, picks one of those addresses, and hands it out to that device on the network. There's a lease period associated with this address, so that device is able to use that IP address for only a limited amount of time. And if that lease is not renewed, that address is then returned to the pool, and someone else visiting that network can potentially be assigned that IP address. An interesting feature of DHCP is that it will keep track of these MAC addresses and IP addresses that it's pairing together. So if you visit this network again, the DHCP server will recognize that you've been here before. And if the IP address you used previously is still available in this pool, you will be assigned the same IP address you had on your original visit. If you wanted to configure an IP address on a printer or a server, and you wanted to confirm that that IP address would never change, you could manually configure those settings on that device. But this does not scale very well, especially in large networks, and if you need to make a change to those settings, you would need to manually visit all of those devices to make that configuration update. Instead, you might want to lock in the IP addresses for those devices in the DHCP server using a feature known as address reservation. Inside the DHCP server, you would create a table that has the MAC addresses of these devices, such as your printers and your servers, and you would manually configure an IP address within the DHCP server that will always be assigned to that particular MAC address. If you look at your DHCP server, you might see this listed as static DHCP assignment, static DHCP, or an IP reservation. Here's the address registration process in one of my DHCP servers. This one has a couple of reservations that I've added. This one is 192.168.1.6. The device name is Prometheus, and you can see the MAC address of that device is listed in the reservation. I also have another IP address, 192.168.1.9. This is the device known as Odyssey, and it has, of course, a different MAC address. By adding these addresses into the DHCP server as a reservation, I can go to one central place to manage all of this information, yet still be assured that those devices will always receive the same IP address every time they're started. As we mentioned earlier, these DHCP addresses are not permanent. They are leased to these devices, and they're only available for a temporary amount of time. This lease time is one that is configured in the DHCP server. Some organizations, they might have a very long lease time. In other locations, it might be very short. You as the DHCP administrator get to determine what the lease time will be for your network. If you were to look at the IP address configuration of your device, you would see the lease timer associated with the IP configurations. If you were to restart that device or unplug from the network and plug back in again, you would be reinitializing that DHCP process and potentially restarting that lease. Another nice feature of DHCP is if you are turning off your system, it can release that IP address back into the pool so that other people would be able to use that IP address in the future.
Tackling your security concerns starts with a prompt. With Sola AI, you get answers to the security questions you really care about instantly. Get started with Sola, the AI you need to get security done.
No matter what kind of teeth you gotta brush, Oral-B Electric cleans better with one simple touch. Oral-B's dentist-inspired brown brush head hugs them, cleans them, and gets in between them for 100% cleaner teeth. Your perfect clean starts with Oral-B.
This DHCP leasing process doesn't wait until the entire lease is complete before trying to renew the lease. Instead, there are different timers that DHCP will use to be able to provide that renewal. The first timer is a T1 timer. This is set by default as 50% of the lease time. So no communication is going to occur between your device and the DHCP server until half of that lease is complete, at which time your device will attempt to communicate to the DHCP server and renew the lease. But it could be that the original DHCP server is no longer operating properly or has been removed from the network. In that case, we go to a T2 timer. By default, the T2 timer is 87.5% of the lease time, or 7/8 of that lease time. With the T2 timer, your device will attempt to renew the lease with any available DHCP server that's on the network. Let's say on your network that your DHCP server is set with a lease time of 8 days. If we do the math, that means the T1 timer, since it's 50% of the lease time, would be 4 days, and the T2 timer, or rebinding timer, would be 7/8 of that time frame, or in this case, 7 days. So under normal operation, we'll go along for 4 days without needing to check in with the DHCP server. But as soon as we hit that T1 timer, we're going to begin a period where we will begin renewing with the original DHCP server. So that renewal is sent to the server, and if that DHCP server is available, it will very quickly renew that lease, and we'll have another 4 days where we can continue to operate without checking in again with the DHCP server. But let's say at this point, that DHCP server is taken out of the network and is no longer available. That means we will go all the way through the renewal period without ever renewing the lease. Once we hit the T2 timer, or the rebinding period, your device will reach out to any DHCP server to try to renew that lease. And on your corporate network, there's most certainly another DHCP server, and it will renew that lease, and the entire timing process starts over again. We often think of DHCP as that automated IP address, subnet mask, and default gateway configuration, but there are other options that DHCP can configure as well, and we refer to those literally as DHCP options. This is a separate field in the DHCP process that allows us to configure other settings that are related to TCP/IP. These options are listed in the request for comments, or the RFC associated with DHCP, Back in the BootP days, we referred to these as vendor extensions. These DHCP options are associated with a number, and there are 254 usable options that could potentially be configured using DHCP. The common configurations for DHCP would be the things that we would normally think about: the IP address, the subnet mask, the default gateway, and the DNS servers. And there may be times when you would like to add additional DHCP options to be configured on that device, but you have to make sure that the DHCP server supports that specific option. Not all DHCP servers support the ability to configure DHCP options. So you'll want to check with your DHCP server to make sure that the options you need are supported by that server. For example, you might have a voice over IP call server on your network, and you might want to add that as part of the DHCP configuration process. So option 129 is the DHCP option for the call server IP address. If you wanted to configure an HTTP proxy, you would use option 135, and there are many other DHCP options to choose from. We're looking again at the scope that's configured within Windows Server under the DHCP server options, and there is an option there for server options, and that refers back to those DHCP options. You can see a list of all of the numbered options within those server options. You can select any of those and define them within the DHCP server itself. Then when anybody connects to the network, not only will they receive the IP address, subnet mask, default gateway, and DNS settings, they'll also receive any of the configurations that you've defined under DHCP options.
Organic and dairy-free.
Here we go.
At Sprouts, our shelves are filled with new, exciting, and delicious discoveries.
With IPv6, we've taken a number of techniques we've used with IPv4, and we've updated them for the modern network. Of course, there's DHCP for IP version 6. Those DHCP servers use a very similar process to what we saw with IPv4 to assign IP addresses with IP version 6. This uses redundant DHCP servers, so it's ready for the enterprise, and you as the DHCP administrator will be managing this DHCP version 6 server as well. But unlike IP version 4, IP version 6 can assign an IP address to itself and be able to communicate with anyone on the network. We refer to this as stateless addressing. There's no DHCP server that manages the process. You don't have to keep track of IP addresses or MAC addresses. And with this stateless addressing, there's no lease time, so you never have to worry about giving up your IP address. An important protocol that's used for IPv6 stateless addressing and other purposes is the NDP protocol. This stands for Neighbor Discovery Protocol. In IP version 4, we use the Address Resolution Protocol, or ARP, to be able to find other devices on the network. But ARP requires broadcast to be able to operate. With NDP, we're using multicast, so the overall communication is much more efficient. The way that an IPv6 device is able to effectively assign itself an IPv6 address is using Stateless Address Auto Configuration, or SLAC. You don't need a DHCP server. The device running IPv6 creates its own IP address to use. One of the concerns we obviously have is that if a device is creating its own IP address, it could potentially conflict with an existing IP address on the network. But in IP version 6, we have Duplicate Address Detection, or DAD, and it checks to be sure that there are no duplicate IP addresses on the network. Neighbor Discovery Protocol can do more than simply find other devices on your network. It can also identify routers using the router solicitation and router advertisement features. If a device wants to find a router that's on its local subnet, it uses this Neighbor Discovery Protocol and uses the router solicitation feature and sends that to a multicast that says, if there's any router out there, please respond back. And if a router sees that multicast, it will send a router advertisement directly back to that workstation.
Okay, everybody,
Routers
welcome
can
back.
also
Welcome
send
back.
their
Welcome
own
back.
advertisements out without
All
being
right.
queried. We refer to those as
Gonna drop some more knowledge on you since we got some time.
they're sent to a slightly different multicast location.
I'm going to share my
Devices on
screen.
the network that might be interested in knowing
What I'm going
where
to show
routers
you
exist.
is
This router advertisement is
Juniper
useful because it can provide information about
dot
local subnets.
net.
Things such as prefix values,
Cool little site.
DNS server
Go ahead and give you this
and other IPv6
URL.
parameters.
HPE.
Now you'll be able to
Here's how Slack or the stateless address auto configuration
log
works
into the
with
site,
version 6.
and this works just like Netcat Academy.
Determine what
So for those that want to go down the yellow brick road of being a network engineer, this is another proprietary, kind of like switching and routing proprietary company that is responsible for these different types of devices on your network to handle a lot of traffic. So this is what you may want to get into. Now the cool thing about this is I want to show you that on this particular website,
as the last 64 bits or the interface ID.
you want to go here and you want to create a free account. So if you want to go in there and create a free account, I have some different things that I can show you while you are creating that. So once you go bookmark this page, bookmark.
This random value or
One thing about Cisco is if you use any of their products and you want to implement that on your network, you have to pay what they call a subscription fee. Cisco's cool, but it's expensive. For all your switches that you have, you want to pay for all those switches to be used in what they call a SDN, a software-defined network, for technicians to remote into that device to fix anything, to load OSs, to get what you need from Cisco, to download what you need from Cisco. All that comes with a cost from the company, okay? Juniper, on the other hand, uses what they call open source OSs, operating systems, and different things you can put on their switches, any third party, to add them to your network so you can control them. Moral of the story, Cisco, proprietary. Use their stuff, pay a subscription fee. Juniper still does switching and routing. They have stuff too, but their stuff's more open source. So you can add it to anything. All right? So that's the difference between the two. Okay, James, how does Network Plus fit into this? You just said Cisco, then you said Juniper. But you're taking Network Plus. Guess what? Network Plus is the basis on operating both of these things. They're both the same. You talk the same language, no matter what piece of equipment you are using. It's just that these two companies have proprietary language that they use. But once you know Net Plus, which is the basic language of any kind of networking, you can understand this very quickly. Okay. Let's get to the meat and potatoes, shall we? Now, when you get into this, you have a button that's called, they go about as partners, talk about solutions. They talk about convergence of AI. AI allows you to have a good convergence, everything working together, using all those routing protocols on your network. There was a Juniper Super Bowl commercial that people did not catch last year. Juniper spent a lot of money. They had like 3 commercials during the Super Bowl last year. All right. Talking about their AI-driven networking. If you go to Learn and click your Learn tab, you'll see a lot of different things. First, one thing I want you to go to when you get there is what they call training. All right. If you go to training, you'll go down to their learning portal. Doink. Once you get into the learning portal, you'll have the login portal once you get here. So you can click that for login.
You have no idea how hard it is to be a single woman in her 30s, okay?
Is it any harder than being a black man in his 60s?
Now the cool thing about this, now this changes. Now this has a shopping cart with a lot of different things that you can try. Okay. Now just like Cisco Netcat Academy, they have some paid stuff you can do, and there's some free stuff. So they have free learning modules, everything. But this is what I want to show you. Down here, they say get started with free courses, but we're not going there yet. Don't go there yet.
And we rely on DNS
You can pay for their all access training pass, which gives you all access to all of their learning modules, whether it's paid or not. Okay, so you can pay that subscription fee. Okay.
But in reality, there are many DNS.
Here's all my training that I signed up for. And this lets you be on the path of a network associate, a network security associate, a cloud associate. Here's your, people can verify your certification so you can get certified. And of course, they go into what's new.
There are also country level TLDs.
Let's go into what we call the certification track.
For Canada, .uk for the United Kingdom, and so on. Here's
Okay.
an example of a DNS hierarchy.
This is what you want to do. Here's the different tracks. They have the associate, which is the ground level.
That is the top level domain, such as
If you want to take their free classes on routing and switching,
underneath those,
you can be the Junos
for example, you could have
associate, and with that,
ProfessorMesser.com, all found by following.
you're learning all of these different things here. Did they break it down? They switched it. Okay. So they have, there it is. Whew. So with the learning path, they tell you what you're going to learn.
For example, you can start with
Networking, technology foundations, introduction to Junis operating system, because they have their own. How to troubleshoot it, intermediate routing, multi-protocol learning, systems fundamentals. Advanced, they show you all of this stuff and what you're going to learn per one. Some they have in person, some you can have what they call on-demand learning. Okay,
and in the West,
go back here.
A separate group of services in that particular area of the domain.
I like it this way so I can go back with the arrow.
DNS to resolve the IP address of many different services.
You can go for data center, security, automation, and DevOps, a lane.
But we also use this for
You're the mathematician, DevOps right there.
Application access.
And then you can do their AI if you want to go ahead and take that career path there and learn how to use AI in routing and switching.
This means we might have two
All right.
or more DNS servers.
But as I go back, this is what I want to show you.
Those redundant servers so that if the first server
They're all on-demand courses.
You'll notice if you look at the configuration
Okay.
of your computer, there are usually two.
Now, if you want to pay the $3,000 to do it, go ahead.
This first one is for the primary
If that's what you want to do, $4,000 4 days. These are all in person.
for your particular DNS
Okay.
domain. Any changes
Or webinar, class, and video. All right. So let me back out of here. I'm just giving you the full walkthrough.
DNS server is not used for primary configuration changes.
Dang, some of that stuff is a year old. Oh yeah, you looking at my training track? Yeah. Why are you calling me out like that? Why are you calling me out? What's up with that? What's going on?
Yeah.
I know I'm slacking a little bit. And here's the thing, Charles. I went through it. I did the learning. You know what they gave me? They gave me a voucher to take the exam, 75% off. All I had to do was pay $50. I'm waiting to schedule the exam.
Yeah.
Lazy. I'm just lazy. I got so much other stuff to do. Oh. So as you back out of here, let's get to the homepage. Oh, no. Go back. There it is. Breathe. Get started. Oh, breathe. Yeah. That's the one you want to pick. Okay? Now, as we get in here, this is what you're going to see. Here it breaks down what you're going to be doing as an, where is it at? Specialist. It's saying if you complete our lower, let's go to associate because that's where you started. This is how it works. If you log in, create an account, start your training for free. You take these optional classes, but you got to take these certification courses. Juno Associate, you can be on that career path, cloud, security, or any one you pick. You complete that. It's going to branch out once you click it. It says here, earn your discounted exam voucher.
75% discount. Yeah.
Complete all of the modules and pass the voucher assessment. So when you go through it, in order to get the voucher, you got to pass the exam 70%. Or higher. You'll receive the 75% off the exam. Are y'all hearing me? 75%
75%
voucher.
Host database, it's simply a text file.
That means all you got to do is pay $50
and the names
to take
of
the
devices
exam.
that you would like to resolve.
Wow. That means this voucher is probably somewhere between $200 or $225 just to sit for it. You get to take it for $50.
That IP address
Wow.
every time I reference
They also give you an exam prep webinar that you watch before the exam, and you get free practice exams. All right. Once you do that, boom, take it, you're certified. Guess what? This is a lifetime certification.
application or your browser to see how it resolves the
You don't have to
situation.
recertify like
That way
Cisco.
you'll know whether the host file is
Yeah,
something
this is
Cisco,
pretty
you have to
good.
recertify.
or whether
Are you learning the same thing as Cisco?
of the DNS server itself.
Yeah, it's basically the same thing.
Is it the same thing you're learning like in NetPlus?
This file
Pretty
itself
much.
is located
Yeah.
Yeah.
The only thing is they go another little step because this is their niche.
This is a file that
They're
is often
talking
stored
about
as
layer
a
3
PDF
routers and
document.
switches.
So if
That's
you
their
make changes
niche.
to this
Okay,
file,
so you
have
get
to change the
more.
files that
You
have
get
read-write
more.
access. And
Okay,
once you do that,
please
you can
take
modify
advantage
the
of
text
this.
within this
But
file
now let's
to
get
have
back to my
IP
year-old
addresses
stuff
and names
that
that
I
you
got
would
called out
prefer
on. Let's go back
rather
to
than
that.
the ones
Let's go
that are
back to this
located
stuff.
on a DNS server. One of the most common uses of
Y'all
a
listen
DNS
crazy.
server is to
Listen,
provide
let's go back.
forward lookup. This means that we provide the DNS server.
Now, if I go back to
and it returns
HPE,
with an
they
IP
changed this
address.
website.
For example, we can send the name www.professormesser.com to the DNS
Let's go to
server.
my
The DNS
enrollments.
server will respond back
Don't
to
judge me.
us with
Don't
the
judge.
IP
Don't
address
judge.
associated
All
with
right.
that full
Let's go
domain
back to.
name. But we can also
Let's go back to
provide the
Judo's
process
associate.
in reverse. We refer to this as a reverse DNS, where we provide the
Bam.
DNS server with an IP address.
You see this?
DNS server gives
The
us
training is
information
free.
on what
This
it
is
believes
the.
name is
I'm
for
giving
that
y'all
IP.
the
This is
411.
something that will need
Because
to
if
be
you would have
reviewed.
just stopped on the first page and say I want all access, you would have paid for it. If you go back, this is the same course you're paying for.
But
If you're not paying attention, they gotta get you.
that's
So what you
crazy.
do is you get this. This is
Okay.
what you're gonna learn. Experience in command line interface, routers and switches, layer 3, routing tables, open shortest path first. You learn all of this stuff. The purchase includes 6 months access. This is the certification track. You get a badge when you get done that goes to Credly. What? And you get I know, Aaliyah.
So the
Amazing, isn't it? All this free stuff on the internet. People don't know about it. And you get that. They tell you about the modules. All that you have to do is click add to cart and you start your 6-month process. Now I'm gonna tell you something funny. Y'all wanna hear something funny? A year and a half ago, I brought my students to this same page. I looked at it and they had just started doing, if you do this you get a free voucher. I said, oh my God, we were in Net Plus. I said, we're all gonna do this. Yeah, James, we're all gonna do it. Well, we forgot. When we got to CYSA, I said, let's circle back around and we'll all sit down and do this.
yeah.
Pulled it back up. It was only 4.5 weeks later. It says you get a 50% off voucher. So they always change it. It's not constant. All right. So you got to catch it. When you catch it, when it's a good one, do it. All right. Because if you get to the final exam part and you get to the voucher part, they're going to honor whatever certification track. No matter if they change it or not, they're going to honor where you're at. So please make sure you at least start. All right. Okay. This is cool. When we're talking about, this is what I like about this class too. Oh, I can't click on it, man.
It's over 2 hours.
Okay, we'll go to the class. I'll bring it up. The reason why I brought you here is because they walk you through. Do you hear Google talking to me? Listen, when you get here, especially for firewalls and filters, they walk you through a lab on how to configure firewalls. All right? It's free. I'm going to bring it up. They walk you through routing tables, how routing tables are built. They talk about BGP, OSPF, they walk you through. And what I like about it is the animation on here is totally dope. It's simple. It's easy to understand.
Yeah.
It's not like Skillsoft from Percipio, okay? They break it down to the very last compound and make it very simple to understand. So that's why I would like for y'all to start with the Juniper Junos Associate track
Okay, so that is the Juniper Associate.
and get that
Okay.
added. Y'all feel me?
Pretty cool. Yeah.
All right. Gotcha. Now we're gonna circle back around at this.
That doesn't feel right.
That was show and tell for today.
There's been other suspicious deaths.
Juniper.
All right, let's get into finishing up our last lesson, and then we can get into some questions for the day. All right, so let's switch over. Let's do this, and then the last part of today in this lesson is talking about physical security. Why did it stop sharing? Here we go. We're back on track. Okay, so when we're talking about physical security, we have to protect those routers and switches and stuff that we just learned about. We have to protect the data.
I'm seeing you right now.
With physical security, the reason why this is coming up again, because Network Plus feels like they have to test you on this. They're going to give you. Do y'all remember the free PBQs links I gave you for CompTIA? Who looked at it?
Yeah, I haven't gotten
Free
live in a
PBQ.
minute. Yeah.
They're going to walk you through a scenario about wireless routers and access to server rooms and where to put stuff. That's actual PBQ that you might see on Network Plus. That's why you might want to walk through it.
Oh, yeah.
And it grades you on it
Oh,
to say, nope, you got that wrong. You should have put it here. They're giving you the answers.
Nice.
Okay. So sometimes CompTIA will give away some PBQs because they know people ain't going to be looking for it
yeah.
on the exam. So walk through that again. Free PBQ links. They're going to ask you some things on the exam, like physical security. Why is it important? Hey, it's the first line of defense in protecting a network and its resources. If you don't protect your stuff, it will lead to a data breach. It will lead to that, right? The risk of bad physical security, of course, it's all of those. I don't need to read those. That's the last one. This is important though.
Mitigations.
The mitigation strategies. If you see mitigation, that means the solution. How are we going to solve the problem? How are we going to mitigate it? A couple of things. Access control systems, put up some surveillance systems. Environmental controls can also help. And audits. Oh, did I mention audits? Yeah, they'll help you to make sure everybody's doing what they're supposed to do. There's some basic things that you're going to be asked. And I know, like, James, this is so boring. Yeah, but the small stuff bites you in the butt on the exam, too. With physical security, you'll see, yeah, hey, Jesus, what would you put to stop people from walking into a building or walking on your property? Oh, I might put some barriers or bollards. Bollards are those things that keep people from driving into something or getting on a piece of property.
Yeah, like
The
fences.
coolest bollards I've seen out in plain sight are the ones at Target. The red bullseyes that sit in front of the store. Those keep people from ramming the front door of the store and doing smash and grabs. That's why those are there. Loss prevention actually designed those things. So in plain sight, they're the coolest ones I've seen. Put electronic locks, bio readers, whatever you want to do. But the biggest thing for rack systems or things or data, that is, you want to put your servers behind a locked door, and they need to have some kind of access control, hint, like a bio reader or a lock, or face, whatever you want to put there. And you might want to put a camera on the outside of the door so you can monitor who went in. Sometimes they don't want a camera on the inside, but you can get away with it depending on the angle of it, because they don't want people to reveal. They don't just get somebody hack the system. They don't want a live feed of what you have in there. You get what I'm saying? So sometimes you want to put the camera on the outside of the door just to monitor entry. Okay. I've seen this question come up. on the Net Plus exam. Hint, hint, open ears, breaker, breaker, one-niner. Cute. They'll say, what can you... It's crazy. Oh my God. He's the hype man. Okay. They'll say, what can you put in place that's free? Well, not free. That's low cost, easy to implement. The questions that you'll be presented is firewall. Remember I said no cost.
Low cost, yeah.
But they'll use the word ACL, access control list.
Yeah.
They'll say firewall,
the overall efficiencies associated
security
with DNS,
guard,
and allows us to have many different DNS queries taking place,
or
but minimize
they'll
the amount of
say Active Directory or something like that.
server itself.
Well, we look at the keyword that says low cost, easy to, a security guard with a sign-in tablet.
And then once the original
Pick that.
query is done,
Isn't
we have
that
information that's now cached
easy
on
to
our local
implement?
DNS server, and any
Low
subsequent
cost, low
requests
configuration?
will have their main name.
Yeah, it's the security guard at the front door with a piece of paper saying,
Let's look at how this
hey Zeus, who are you here to see today?
occurs.
I'm here to see Mike.
No previous queries have been made for this.
Let me look at the access control.
Nothing is
Sorry, man, you're not on here.
stored within any caches.
That's part of physical security.
Making the request.
The old school ways of having the guard at the front vestibule asking you who you're here to see. You sign in, they call Mike down. Hey, we got a lane down here to see you. Mr. Wiggins, you ever heard of him? Yep. Oh, great. Okay, great. Yeah, he's down here waiting for you. They sign you in, and then Mike will have to escort you everywhere in the building, and then he has to escort you back to the front and sign you out. Okay? I thought it was just decorations. Oh, the security guard?
So how does our local
They do look like Christmas trees.
the fences.
What's going on with that? That's what you're looking at. With rack systems, again, secure them, put them in an enclosure.
So the local name server is
You might want to put those dang, those need to be replaced. They look old, don't they? Yeah. Okay, now we can upgrade. Okay, so you have the pan tilt zooms, cameras on the outside of the building. Those ain't nothing but weatherproof cases. What's really important is the camera that's on the inside. It's locked in there. So that's just a secure case, so nobody can mess with it.
server does have a record that shows
But as a detection-based control, this is what you want. Detection-based controls is some kind of security appliance that can monitor. You also may have a laser. Maybe if the laser is broken, somebody walks through it, this is a laser. It sets off an alarm. Or you can be like Nellis Air Force Base, who has the dogs, the electronic dogs that walk the perimeter. They're called Wanda Envision. I told you about those dogs, right? A student of mine brought one in. He was retiring from security forces. It was his job to take care of Wanda. He brought Wanda into the classroom. All we heard coming down the hall was boom, 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 boom. Then she marched into the class and went, zzz, 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 zzz. Yeah, crazy.
Yeah.
But it was cool to see. I got pictures if y'all want to see it. I'll upload it.
Nice.
But Wanda was dope. She can be outfitted with night vision, weapons. You heard that right. You can mount a rifle on her, or she had a pistol mount that you could put on her. And she could hold a light machine gun. There's also a heat sensor on her and something else. So she could be outfitted with different things.
Yeah.
Now, let me be clear. And nowhere on this base has she been approved to carry armament. Okay. But she can be outfitted with armament if she had to.
Have you guys ever heard of the Metcalf incident?
No, tell me about it.
It's basically this, like physical security. I guess they were never caught, but in 2013, I guess the tactical team went into like a transmission substation. At 1 a.m., they entered underground, cut fiber optic cables, and fired over 100 rounds at 17 transformers. And it took like over a month to repair, and they were never caught.
Wow.
$15 million in damage.
Mm-hmm. There's, we have so much out here that's unguarded. Look at what's going on with the rail. We have rail, right? We're so busy about airplanes. It's like we're ditching rail. Rail right now is being demolished. In Chicago, in the rail yards, that's where I'm from. I know where the rail yards they talking about. Navy submarine bases, marine mammals. Yep. Just joined the Dolphins. Yep. The Dolphins joined the SEALs. Yep. That's a real thing. But they're stealing iPhone inventory. They're stealing cell phones. They're stealing cars. And this is product sitting on the trains for months, if not weeks, until they get transported somewhere else. It was a big scandal where the who's the person that's in charge of making sure that stuff's locked down, like the load master or whoever you want to say. They found out that he was recruiting the gangs in Chicago, and they would come and rob the trains because he'd tell them what's on the cars and he'd mark them. Crazy. Like, it's a sting operation. But it's wide open. You got thousands of miles of rail out here, and ain't no security out there. But they're trying to get drones and stuff to get approved to surveil all that land, right? Do you know have drones that surveil the border? Border Patrol. I have a friend in Border Patrol down in Texas. She's down there, and she's not in the drone program, but she has a friend down there who's responsible for monitoring the drones and 24-hour surveillance that just fly the whole thing. So it's pretty cool. With camera types, you have your fixed camera types, pan, tilt, zooms. What you need to know is that when you have a closed circuit TV network, all of that stuff is put together with the cable, RG6 cable, with the terminating ends, the bayonet connectors. Those are the ones that you're going to see terminating CCTV mostly. They're moving over to RJ45 and different things, but primarily you'll see RG6. And as you can see right here, it says right here, they're going over to RJ45 because you're able to put power over Ethernet over those cameras.
Yeah.
Right, and control it on the server. You can use geolocation, of course, put virtual boundaries. We can get past that. We've kind of went over geofencing and geographic extensively. There's only a small number of things you can do with it, but you can block people out, box them in. They have to work in this area. If they step out, it turns off, or you can just track folks, right? So basically, that's what you're doing. All right, so in this lesson, we looked at with perimeter defense. Utilize firewalls, proxy servers, and screen subnets. We talked about that. Internal zone protection. You can implement firewalls for internal zones. Intrusion prevention and detection systems we talked about. And then earlier today, we talked about IoT, Internet of Things, and how we could use these items to help you monitor systems. And then site access controls, which pretty much comes down to perimeter security and physical control.
Yeah.
Make sure that that's implemented correctly. Well, look at this. We got two questions. First one, the city has decided to enact a smart city initiative to reduce traffic congestion. It will use real-time tracking of vehicles entering and exiting zones to automatically adjust traffic signals. Which type of following technology will they use?
This is the record containing the information we need when we send a query to a DNS server. Records marked with an A.
If they're adjusting traffic signals,
you often see the IPv4 address and the name of
that means the signal is stationary, right?
Yeah.
The traffic signal?
Records marked with 4A
Okay.
or quad A.
They want to see who's entering and exiting
This provides
the zone.
functionality with both IP version 4 and IP version 5.
Who read that real fast and picked number one?
Record is different, where IPv4
All right.
has 1A and IPv6
I did.
has 4
Yep.
A's.
When I looked at it the first time, I was like, geo tracking. No, how you gonna track a car? Wait, that's too much.
Yeah.
They specifically said tracking a zone. What comes in and out of the zone.
Has an A, which is
RFID. Charles, RFID tagging. That could happen though.
Yeah.
Depending if it's inventory
Yeah.
or GPS. You could use both of them if it's tracking of inventory.
Yeah, I'd be.
You pick 3 first. So we got to look at it. So the most logical one to pick is geofencing.
Sometimes
you have a camera pointed at the intersection. You can, just like your security camera at home.
Yeah.
You're drawing a box.
Yeah.
When it comes in and out of the box, you're tracking what's coming across the box, right? So it counts what goes in, what comes out. So I picked geofencing. 2, in a corporate office, Jeanette with the IT department is upgrading the network infrastructure to enhance security for the authority and accessibility. They are particularly.
And that chat alias is pointing to mail.example.com.
I'm getting giggly. Is that part of the day?
Yeah.
Get it? Is that particular part of the day?
Yeah, I'm particularly
Dad
concerned
joke.
about it.
Concerned about the physical security of the network switches housed in the server room due to the sensitive data they handle. What type of rack mount should the IT department prioritize? Michael says, I just got back and got to check on the kid. I'll be back. Okay, Mike, we will await. So, which one did y'all pick? 3?
Yeah, because it's
Yeah, me too.
Yeah.
Of course not. I do that. When would you do? Well, that's kind of like an open-ended question. You would pick a wall-mounted rack when it's something in a room. Like I have mine up here, and I have little routers and stuff up here. You want to keep it out of the way,
Yeah.
and like that room might need a small switch just to handle that traffic in that room. So you'll just put it up high and lock it. It's pretty much gonna have LAN cables coming in and out, cat cables, and then you can distribute there. Okay. So you can have a whole bunch of LANs on there. It might have a PoE
Yeah.
access point in the middle of the room, right? Just so you can get on the net, and then it'll transmit it back to the server. So just different ways you can do it. That's cool.
Yeah, perhaps segmented through.
That was the end of today's brief. Are there any questions? Oh, what's the answer for one? Let's go back.
At this point, if you needed to send mail
Good question.
directly to that mail server, you would have to perform
And it is
a
geofencing.
resolution to mail.example.com.
Yeah, geofencing.
So as long as there is
Yep,
a
it's right there.
you'll be
Bam.
able to resolve the IP address associated with that mail.
You go with geofencing because you can do the box, anything coming across. Yep. Now, RFID tagging, I used that when I was doing loss prevention for stores.
Here's an example of one
You're tracking inventory. RFID is like that's how I used to verify shoplifters had stuff on them, because there's a 5-step process. They gotta walk into the department. You gotta see them walk in. You have to see them select. You have to see them conceal the item. You have to see them conceal the item. Then you have to give them reasonable surveillance. And the last step is you have to watch them cross the last point of sale. Then you can apprehend them. So what used to help me if I lost track of the item is I had to make sure my door alarms worked. Because I'm like, I know they took that polo sweater. But the way it looked, I saw them put it in the bag. Sometimes you second guess yourself and you following, and you hope they go out the door because the tag is still on it, and then it goes boop, 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 boop. Bingo, got you. And then I'm apprehending them at the door. Yeah. Yep. Then I'll be like, freeze. No, I'm playing. I don't say freeze. I just walk up to them and say, hey, how you doing? They say, hey, how you doing? And I say, can we talk for a second? And they'll be like, what do you want to talk about? I say, can we talk about the polo sweater you stuck in the bag? I will put it like that. What are you talking about? Let's not be stupid. You were back there by the underwear. You bent down. Get under. Come on, let's not make that harder than what it is. Darn it. Yep. Come on. Once you start calling them out, they're like, how'd you know that? Here's a funny story before we go on break. I was following somebody around the store for an hour while they were shoplifters. I talked to them 3 times. 3 times in an hour, I said something to them. Now, mind you, each time I talked to them, I had a different hat on and a different shirt, because I would always run and change clothes. I snatched clothes off the rack, put something else on. So I had 3 different looks I gave them. So when I apprehended them, I'm like, I was the one over by the the cologne, remember?
You can
That
find
was,
these
yeah, then I saw it. And then we look at the video together while they in handcuffs. So I'm like, see, there I go. That was you? Yeah. I was trying to give you a chance, but you still kept still. You know.
Yeah.
See a video with a lady put over 50 pounds. Yeah, they put on, yeah, man. Some people steal some stuff. I cannot tell you the weirdest one I had. This is not the place for it.
Yeah.
Let's just say,
Yeah.
y'all will be able to figure this out. See, Brian wants me to tell the story. With the look he has on his face. Who wants me to tell the story?
Yeah.
Okay.
Yeah.
Now, let me put a disclaimer out before we go to break. I'm going to say this the most politically correct way. It's an actual thing that happened, but I'll leave it to your imagination. Is that fair? Okay. Two girls come into the store. Martin's like, oh, here we go. Two coming to the store.
Yeah.
Busy. They go over to the bright one, the necklaces. They pick 3 necklaces and some rings. The person turns around. I was like, oh. I zoom in on the camera. She takes 2. It's like, okay. They walk into a fitting room, which is probably 20 feet from where they took the necklaces. Now, at this point, I run out the office. I'm running over there and waiting. I send somebody in there. I say, go in there and just kind of listen and see what you hear. Because they're supposed to clean the stalls out. I'll call ahead of time and say, clean out. I don't want nothing in there. So when I go in there, after they leave out, I quickly run in there. Brighton tags. Right in the corner. I'm like, that's what they took. There you go. Okay. Following them out. Now, here's what happened. When they got out the store, they split up. I don't know who got what. But I know they got something. They was in there together. So I went and grabbed the one girl, the one that didn't take off, brought her back to the office. I'm in there talking to her. I said, can I have my necklace back? I don't know what you're talking about. I said, let me get my necklace. Now I'm getting nervous. So I called my boss. After a certain amount of time, you got to call somebody. So it's after 20 minutes. I said, she's saying she ain't got it.
We can start whenever.
Now he's yelling at me. This is a lawsuit for the store. What happened? Blah, blah, blah. I said, no, trust me, she got it. I got y'all on the edge of y'all seat. Let me tell you what happened. So he puts on, he gets on speaker. He says, ma'am, do you have it? She says, no. He says, James, you better go rewalk that whole store and take her with you. I said, I know you got it. She's like, nope, I ain't got it. I was like, okay. Got him. She said she ain't got it, but I know she got it. So I put him on speakerphone. Here's what happened. He says, ma'am, I know there's probably some, this is what she said. I gotta leave in time to pick up my baby from the bus stop. He says, oh, are you concerned about yourself for the bus stop? Yeah, I have to be there. I don't want to miss again because I'll get in trouble. He said, what do you mean get in trouble? He says, well, before I missed him getting off the bus and then child services came. He says, why did child services come? Well, I got arrested for shoplifting. Boom. She admitted she had just got arrested for shoplifting 4 weeks before that. And then my boss was smart enough to say, so you probably don't want to tell me you're shoplifting today because you're concerned about your child. She stopped, she looked, I said, got her. She's like, yeah, I don't want to admit, if I did, I don't want to say I did because I know I'm going to jail. He said, well, let's make a deal. You give me the necklace back, you walk out of here free. I don't call the cops. She said, you're lying. He says, I don't lie. I said, yeah, my boss don't lie. He said, that's what's going to happen. That's what. Let me get to the story. I had a female take her in the bathroom.
I'm lying. I'm not going.
She produced it.
Yeah.
From the front.
Yeah.
I'm going to leave it like that. Shoplifters are creative.
Yeah.
She held out for a good hour.
Yeah.
But with that inquiry, maybe you don't want that. Well, we did not want it. They tried to hand it to me. I said, I see it, throw it away. Don't want it. We can write it off as a loss.
Yeah.
But I say that to say this. People are creative. Data loss prevention, same thing as loss prevention in the store. You're trying to keep somebody from coming in and taking your stuff, right? It be a physical item or data, right? So hopefully that was the most political, nobody was offended or whatever, most politically correct way to give you that story. But yeah, pretty funny.
Log files and other information.
Woo, that day wore me out though, mentally. I was like, ooh, I thought, man. But great stuff. What? Mr. T said, some habits die hard. Don't. Jesus says, you didn't, okay, you think it was the necklace from the Titanic. Exactly. The way she was holding it, it's a bright necklace. Granted, they're expensive, but it ain't the Hope Diamond. Come on now. Saw a few videos. Yeah. Death rings. But I had a great run. I was a private investigator in loss prevention for like more than 10 years, so I just seen a lot of stuff. All right. Okay, y'all. Let's take a break. Let's do that. Let's take 10. I'll see you when you get back. Have fun.
A separate NTP client that then queries a different NTP server. The client is the software that's responsible for querying the server and obtaining the latest update of time information. And in some cases, we might have both an NTP client and an NTP server on the same device. The server is handing out timestamps to any of your NTP clients, and then if you need to update the time on that device, a separate NTP client on that device will perform the same query to a different NTP server. Some organizations query an external NTP server to provide that time information. But if NTP is important for your organization, you may choose to have your own NTP server. You would then configure all of the NTP clients on your network to query your own internal NTP servers. By default, NTP sends information in the clear. After all, the time of day is not something that's generally private, so it's common to send this in a non-encrypted form across the network. But time can be an important security concern. For example, Kerberos is often used to authenticate devices on a Microsoft Windows network, but Kerberos won't work if the client and the server's timestamps are off by more than 5 minutes. So you could potentially cause a denial of service by providing the wrong time to all the clients on this network. For that reason, we need some way that we can trust the response that we're getting from these NTP servers. One way to do this is by using Network Time Security, or NTS. This adds a level of authentication so that we know the response that we're getting back from these servers is one that can be trusted. To use Network Time Security, we need an additional device on the network known as the Network Time Security Key Exchange Server. This is a server that's responsible for authenticating the clients and making sure that they all have a cookie that can then be used to perform the NTP query. So this now turns into a two-step process where we first obtain the authentication details and then provide that cookie to the NTP server. Here's a better view of this. We first have a TLS handshake that occurs between the client and the NTS Key Exchange server, and then we can request a cookie from that server and then receive it in that response. From this point, we can perform the NTP request to an NTP server, but we include that cookie information to show that we have authenticated to the Key Exchange server. We can then receive the NTP response, and we now know that we have a valid timestamp from a trusted server. With a local NTP server, we can get accuracies down to around 10 milliseconds. But in some environments, we need very precise time synchronization, and we can do that by using Precision Time Protocol, or PTP. This is a hardware-based time synchronization that provides granularity down to the nanosecond. This is especially important for industrial uses where you need to make sure that the timestamps across all of these devices are very precise. PTP often requires a separate piece of hardware that is separated from our operating system and any of our applications. Own operating system, it can run without any delays from any type of third process, and it can provide the most accurate timestamps for all of your devices.
Looks like Jungle in Paradise as the hottest festival of the year has flamed out.
You wanted to...
A VPN is a virtual private network. That is a way of taking information that would normally be sent across a network in the clear and encrypting all of that data so that we're then able to send it over a public network such as the internet. If you're using a VPN from your workstation, then you're probably connecting to a VPN concentrator. This is a functionality that's usually built into our modern firewalls that allows us to encrypt and decrypt information on that concentrator. This means we can encrypt information, send it across that public network, and on the concentrator we can decrypt that information and send it on its way. This might be a piece of hardware that is specifically designed for this encryption and decryption process, or all of this may occur within software that we can install on an existing server. VPN clients can be installed on many different operating systems, and some operating systems may include VPN clients built into the operating system itself. If you're using a client-to-site VPN, then you would have software that's installed onto the client workstation, and that client workstation would be communicating back to a central site. For example, you could be using a laptop at a coffee shop, and you may want to enable this VPN functionality so that you can communicate securely to a concentrator that's located on your corporate network. Sometimes this is software that you can manually enable or disable depending on when you might want to use it. But some VPN software can be configured as an always-on connection. So when you turn on your laptop and log in, it has already created the VPN connection back to your corporate network. So you would either start your VPN software and enable it manually, or that software would be automatically loaded, and as soon as you begin sending information across the network, all of that communication will be encrypted. When that encrypted data is received by your VPN concentrator, it decrypts that data and then sends all of that into your internal network. Whenever you're sending information back to the laptop, it reverses this process where it takes the information from the corporate network, encrypts it, sends it across the internet, and it will decrypt down at your laptop. Another type of VPN connectivity is between different sites. This is a site-to-site VPN where all of the communication between one site and another is encrypted over this VPN tunnel. This is something that's commonly used as an always-on connection so that you can be assured that everything between those locations will always be encrypted. This is usually built into an existing firewall. So you would turn on the VPN concentrator function on each firewall at each location, and you would have all of the data sent between these locations traverse this encrypted tunnel. Of course, the concentrators will be decrypting this data on either side of the connection, so the users at the different remote sites have no idea that this data is being encrypted between the two locations. Instead of installing a separate piece of software just for this VPN connectivity, your organization may choose to use clientless VPNs that don't require any specific VPN client. This is something that usually runs inside of a browser using HTML5. This is the Hypertext Markup Language version 5. HTML5 allows us to use an application programming interface to be able to interact with the browser. And one of those APIs is a web cryptography API, which allows us to run a VPN client inside of our browser without using a separate client. This means we don't have to install any additional software. We just visit the appropriate web page, and the VPN software within that API takes over and provides that encrypted tunnel. All you have to do is make sure you're using an HTML5 compliant browser, and you'll be able to use this clientless functionality within the browser on your system. The administrator of your VPN system may configure the connectivity in a number of different ways. One of these methods may be through the use of a full tunnel. A full VPN tunnel means that all traffic that's being sent out of your machine is traversing that VPN tunnel and is encrypted on the other side where the concentrator is located. Your local machine doesn't make any special forwarding decisions where some traffic is sent through the tunnel and other traffic is not. Instead, everything is being sent over that VPN connection. In some cases, though, the administrator of your VPN may configure a split tunnel. A split tunnel means that some traffic will be sent over the encrypted VPN, but other types of traffic, perhaps something that is not related to your corporate environment, is sent outside of the VPN connection. So let's take this scenario where we're using a VPN. We are connected over this VPN connection to a VPN concentrator that's at our corporate office. But we might also want to communicate to a web server that's on the internet that's not part of our organization. So you might want to connect to my server at professormesser.com. This means that normally traffic that's destined for your corporate network would go from your remote user's workstation to the VPN concentrator. That would then be decrypted and sent to the inside of your corporate network. But if traffic needs to go to ProfessorMesser.com, that traffic still needs to traverse that VPN tunnel. It is decrypted at the concentrator, just like all of the other VPN traffic, but then is redirected to the internet into the external web server. Any communication back to the client would then need to go back to the concentrator and then be sent back through that VPN tunnel. With a split tunnel, we can avoid that additional routing that occurs when you're talking to a third-party website. So now at the remote user's workstation, we effectively have two different paths. We have our VPN tunnel back to our corporate network, and then we would have a separate path that is used for other third-party traffic. If we want to communicate to our corporate network, we would send that traffic through the VPN as usual to our VPN concentrator, which then decrypts the traffic and sends it to our corporate network. But if we also, at the same time, would like to communicate to ProfessorMesser.com, we would then, at the remote user's workstation, simply send that traffic as normal. The VPN client would recognize that we're talking to a device that's not part of our corporate network and would directly send that traffic to the third-party website without traversing the VPN tunnel. And of course, the traffic back to our device would also not use that VPN connection. This means we can continue to have an encrypted and secure connection to our corporate network, but use a more efficient process of communicating to third-party websites.
Cybersecurity today is so messy and expensive. Why does it take so long? It really shouldn't be that. Get started with Sola, the studio where you can build any security app. Whether you're the security person or just the person tasked with security, tie together some loose ends or build up your security stack. You fit Sola to your needs. It's simple, quick, and free. Get security done with Sola.
If you've done anything in networking related to switches, routers, firewalls, or other devices, then you've probably connected over the network to a terminal or console. To do this over an encrypted channel, you use a protocol known as SSH. This is Secure Shell. This allows you to use this terminal screen to a remote device, but all of the traffic sent over the network is encrypted. This means you can put in your username, your password, and all other information, and no one else will be able to capture that traffic and see any of that important data. Secure Shell operates using TCP port 22, and it's designed to replace a protocol known as Telnet, which uses TCP port 23. Telnet is very similar in operation to SSH. It provides this console-based view of no encryption, and that's why the best practice is to always use SSH and not use Telnet. Working at a command line is useful, especially on devices that support it, but occasionally you need to be able to provide remote access to a graphical front end. You can do that by using some type of remote sharing software so that you can be at a remote location, yet still see and operate the same desktop as someone who's sitting directly in front of that computer. If this is a Windows computer, then you're using RDP, which is the Microsoft Remote Desktop Protocol that allows you to connect to a Windows machine and be able to access and use the front end as if you were in front of the actual monitor and keyboard. If this is a Windows computer that you're connecting to, you're probably using RDP, or Microsoft Remote Desktop Protocol. This allows you to remotely control a Windows machine, either from another Windows machine across the network, or by using Remote Desktop Protocol clients that are available for nearly any other operating system. Another option for remote control of a device would be to use VNC, or Virtual Network Computing. This uses a protocol known as RFB, or Remote Frame Buffer. This is very similar in function to Microsoft's RDP, but the VNC functionality can be run on many different operating systems. If you're part of a help desk or support team and you need a way to remotely connect and control any of these remote desktops, you're probably going to be using RDP or VNC. Sometimes you need to be able to make changes to hundreds or even thousands of different devices. You could automate this at the command line using scripts and batch files, but because this operates at the command line, you don't have a lot of control over the process if you have to run into problems. For that reason, you might want to use a more automated method of controlling a device using an API, or Application Programming Interface. Using an API, you can connect and control a device using the language that that device would expect. This also allows us to automate the process and set up additional tasks if we need to do any type of error handling. If you happen to be in the same physical location as the device, you may be able to plug in a cable and directly connect to the device. With switches, routers, and other infrastructure,
All right, we are back.
you might even have a separate port on the front labeled console. That console allows you to connect to a serial
So what I have on the screen that you see is an example of one of the classes that you'll see for Juniper Networks once you get in there. It goes over dynamic routing protocols, which is pretty cool. You're going to see dynamic routing protocols on the exam, especially at least 3 questions. So you have to know the difference between dynamic, static routing, linked state routing, and what's the other one? Starts with a D. Linked state routing and y'all forgot it.
The link state and
Distance vector.
Instead of individually
Distance
connecting to
vector.
devices,
But here's an example of what you'll see.
will create a jump server that allows you
Welcome to the Routing Protocols and the Problems They Solve module. By the end of this module, you should be able to explain how routing protocols solve the problems of static routes.
All you do is go to the bottom, you click go ahead, boom, hit the arrow.
to the jump server.
Once again, before you dive deeper into dynamic routing protocols in this module, let's take a quick moment to review what you've learned about them so far in this course. Static routes require a lot of manual work. They require careful planning to create, and they require maintenance to maintain over time as your network topology grows, shrinks, and changes. By contrast, routing protocols automatically learn remote subnets. In particular, when you enable a routing protocol on a device, your router will do 3 things. It will learn about remote subnets, advertise its own local subnets, and re-advertise remote subnets that they've learned about from other routers. When this is done correctly, the result is that every router in a network will have learned routing knowledge for every single subnet that the device is allowed access to.
Connection on a switch, router, or other device allows us to directly connect, but very often
Dynamic routing protocols solve all of the problems associated with static routes. First of all, and perhaps most obviously, routing protocols are able to automatically find the best path to all destinations. There is no need for manual planning when you run a routing protocol. Second, routing protocols dynamically react to changes in the network. This means that not only do they find the best path, but they also find new best paths when links and routers are removed or added. Depending on the protocol you use and how you set it up, this process can potentially take place in the blink of an eye. For example, this is the topology of 5 routers that you saw in that previous module, titled Static Routes. Notice that the routers are called A, B, C, D, and E. Router E has a LAN subnet attached to it. At the moment, there's a big red cross through router B to indicate that it's down. Just for a moment though, imagine if this router was up. In this case, router A might choose B as the best path to get to this LAN. Thanks to routing protocols, router A will make this choice on its own, without you having to explicitly configure it. All you need to do is enable a protocol of your choice. Now imagine that B suffers a fault. In this situation, A can automatically find an alternative path via C. With this example, the power of a dynamic routing protocol becomes clear. Even if the network changes, all routers will still automatically and dynamically learn what IPs exist on the network and the best way to get to them. With a routing protocol, you don't need to make these changes manually. There is a third problem with static routes, which are solved by routing protocols, which is the fact that a static route has no visibility of the routing information that is known by the next hop router. For example, router A has no idea if router B is capable of forwarding packets to a particular destination. This problem is implicitly fixed by a routing protocol. After all, if router A learns a router to E via B, then this only happens because router B told router A about the route in the first place.
This is a team feeling zen.
Routing protocols also bring extra integrity to the routing knowledge in a network. Before routers exchange prefixes, they first agree on how the protocol works. Two routers will exchange a series of initial messages that indicate their settings for the protocol. Things such as timers, for example, how often the router will send messages, or how long the router is happy to not hear from the other router, packet sizes, and other important protocol-specific settings. If two routers agree on how the protocol works, then, and only then, will they exchange routing information. This process is called forming an adjacency. You'll also hear it described as becoming neighbors. When two routers agree that they talk the same protocol in the same way, the two routers are described as adjacent, and are also described as being neighboring devices. Thanks to this process, all the routers taking part in the protocol can be confident that the messages they're sending and receiving will be processed in the same way by the remote device, and indeed, that the device is live, active, and able to receive traffic that should be forwarded onto its destination. Don't be confused if you sometimes see people talking about a neighbor relationship, or just a neighborship for short, and sometimes talking about an adjacency. They are two terms for the same concept.
The requirements for security would come from other devices, such as firewalls.
All right, so what I wanted to do, just give you an example on that, what it looks like. I can keep going. You want to see the last three slides?
Or blocked, and then look inside the
Or you want to look at it on your own?
make sure that none of that information is.
Let me tell you where you can find it at. That way you know. So if we were to lower this, let me bring my other screen.
TLS, which is transport layer
Bring up screen
security,
2.
and IPsec.
This is what you're gonna see.
If you're saving information,
So what I did is,
SSD or any other type of storage device, we refer to that data as data at
Charles,
rest.
I re-signed up for the
One common way of
class.
encrypting data at rest is to encrypt the information as you write it to the storage drive. This means
Put it back in my learning locker, and I checked out. So when you sign up for it, you'll check out, you'll select it.
Some different types
Let me go to
of
my learning
data at
portal.
rest
I'll show you how I did it.
Include the entire disk using full disk encryption. You might encrypt just one single part of a database.
Get started
or
for
entire
free.
database of information, or you might encrypt individual files or folders in the
Why
file
it's taking so
system
long
of that
today?
operating system. And in most cases, we're applying different security policies to the data that we're storing on these devices. For example, we might create access control lists, or ACLs, that would determine what users have access or no access to a particular type of data. This would allow the system administrator or the
Open Learning, CCNA, you can do add to cart,
security controls are usually part
and you
of
do
the
thing. It's free.
might be at rest.
Purchase it, still zero. Hit continue. You got 6 months to finish this, and then they'll honor a voucher for you.
We refer to the policies and the control of
All right.
these different certificates as a public key infrastructure.
And that's what you do.
PKI.
Now this is in my learning locker. So all I would do is just click on it, boom, boom, boom. Juno's routing, policy, and firewalls. Make sure you don't have pop-ups. Disable pop-ups on, and then you'll get a pop-up of the class. Boom, and you just start playing it. As such.
And there's often changes in policy as time goes on.
Pretty easy.
Many organizations will begin building out their public key
Right.
infrastructure when they
That's all the magic tricks I had for y'all today. I exhausted all my magic today. Any questions?
Or individual devices. The PKI then becomes a requirement.
All right, so we're cool.
And managing
All right, I'll let you turn to it, and we'll just finish out the day.
One challenge that many organizations have is applying a level of trust towards a user or a device. One way that they can assign this trust is through the use of a digital certificate. Digital certificates are often digitally signed by a central certificate authority, and that's what adds the trust to these individual certificates that are then deployed to users or devices. Instead of having a centralized certificate authority, some organizations will use a more distributed form of trust called a web of trust. With a web of trust, if A trusts B and B trusts C, then A can also trust C. This process of creating certificates, a certificate authority, and then providing digital signatures for those certificates is often built into central operating systems. For example, the certificate process is built into the Windows domain services. There are many third-party options that you can use for many different operating systems. One of the more common ways to provide this trust in an organization is through the use of a certificate authority. This is a centralized authority that all certificates start from. This means that if anything is signed ultimately by this centralized authority, you can trust it anywhere in your organization.
An irresistible scent combo. Game Tango Scent Boosters.
At Sprouts, our wide open layout invites you in.
I know that all.
With healthy around every corner and tasty on every shelf. This is that Sprouts feeling.
Some organizations will build their own certificate authority within their organization, but other times they may use a third party as an independent authority. Whether this CA is a trusted internal resource or it's a trusted third-party resource, the CA is responsible for the trust that we have in all of the certificates that we create. And since the certificate authority is digitally signing all of these certificates, anyone can examine a certificate, see who signed the certificate, and then determine if that is a signature that they can therefore trust. On the internet, it's useful to have a third party provide trust. That way, anyone in the world can reference that certificate authority and know that there's a trust associated with those digital certificates. But if all of your devices and users are within your own organization, you could create your own certificate authority. This means your internal certificate authority will be self-signing all of the certificates that are created. This means you can get public off-the-shelf software to build your own certificate authority, and then you can start signing your own certificates within your organization. And as long as all of the users in your organization can trust the CA, they can therefore trust any of the certificates created by that same CA. When we store important data on our systems, we need to be sure that only the authorized users are able to access that data. This is something that is a common issue for all the types of data that we use across all of the different systems that we're accessing that data from. This is complicated by the fact that this data could reside anywhere. It could be on our local computer, it could be on a central web server, or it could be stored in the cloud. This data might also need to be accessed by many different individuals that have different rights and permissions to that data. Some of this data may need to be accessed by customers or contractors, or you may need internal users to gain access to that data. We also need to be sure that we have controls in place to prevent any unauthorized users from gaining access to that data. The process of managing the permissions and access to that data is referred to as IAM, or Identity and Access Management. This involves creating an access control to that data to ensure that only users access the information that they really need to perform their job, We need to be sure we have proper authentication in place so that we can verify that that's the user accessing the data, and we need to be sure that we provide authorization for the data once those users gain access to the network. And of course, there needs to be a way to track and monitor access to the data so that we're able to audit and understand exactly who accessed that information at any particular time. An important characteristic of identity and access management is the concept of least privilege. Least privilege is the concept that a user will only have the rights and permissions that are necessary to access the information they need to perform their job function, and no additional access would be granted. This is one of the reasons that we don't assign administrator access to every system that's on the network. We need to be sure that we are limiting how much access a user might have to an application or to data, and we need to be sure that the applications that we're using have just the right access for that particular job function. If you give users too much access to data, for example, give everyone administrator access, then everyone would be able to access any type of data at any time and be able to control it in any way they would like. That would obviously be a significant security concern, and it's one of the reasons that least privilege is an important concept in identity and access management. One way to provide this least privilege is through the process of a role-based access control. Most organizations will separate individuals into separate roles. You might have a shipping and receiving department, there might be a manager of that shipping and receiving department, and there might be a vice president that manages not only shipping and receiving, but also the accounting department. Each one of those users has a particular role within the organization, and their rights and permissions will be different depending on their role. With role-based access control, the administrator of the network determines what type of role an individual might have and what permissions might be associated with that individual role. The administrator would then assign users to each of those role definitions. So there might be a shipping and receiving role for the people performing those functions. There might be a manager role for shipping and receiving, and there might be a vice president role that handles many different aspects of the data across the entire organization. In Windows, we provide this role-based access control through the use of groups. We would create a separate group for each one of those different roles, and then we would assign users to those Windows groups. Another way to limit access to data is through the use of a geographic restriction. This means that we would identify where a user happens to be, and then we can assign different rights and permissions based on where they may be located. This can sometimes be done with an IP address. If somebody's connecting over a VPN, they might be assigned an internal IP address, and we might provide them with the rights and permissions that are expected for someone that's connected to our local network. But if they're connecting from a different state or a different country, we might want to change the type of permissions that user might have.
Compliments of the chef. Oh? He was so glad that he had emergency roadside service with Geico. And since they saved his bacon, he presents to you a bacon tart flambe.
With Vic, mate, look, I don't need special treatment. I'm just happy that he's happy.
You're too humble, Mr. Gecko. Which is why we also present to you, and I don't need special treatment, run-of-the-mill grilled cheese.
Oh, now we're talking.
Yes, we are.
Okay.
Get more savings in service. Get more with Geico.
IP addresses are not always the most accurate, so there might be other ways to determine a geographic location for a user. For example, we can use GPS or the Global Positioning System to determine where a person might be in the world. If GPS is not available, we might want to use the name of the wireless network where someone's located, and often we can determine the location of the access point to determine where the user might be. Once we know a user's location, we can then start assigning rights and permissions to where that user may be located. We refer to this as geofencing. Geofencing takes into account where a user might be and then allows or disallows access to information based on a physical location. For example, certain data within the organization might be very sensitive, and you may only be able to view that information if you happen to be located in the corporate headquarters building itself. If you're outside the building, you may not have access to that data. Many physical security through the use of cameras. Sometimes we refer to this as CCTV, for closed circuit television. This is a very common security technology and one that is implemented in nearly every organization. Some of the more modern cameras can not only provide motion detection, so you know if anyone happens to be in a particular area, but they might also be able to read license tags or be able to identify a user based on facial recognition. Usually there are many different cameras deployed in locations around a building or a campus, and all of those cameras are networked back to one central point where they can store this information over a long period of time. This allows the administrator to go back in time and view every video feed that may have captured information during a particular time frame. And if we're talking about physical security, we're also going to talk about door locks. A conventional lock uses a physical key to be able to gain access, and it may include additional security through the use of a deadbolt. Larger environments might have electronic readers where you would put in a personal identification code to gain access to a door, or there might be a token-based access such as the RFID badge associated with this electronic reader. Or we might not use the badge at all and instead focus on characteristics of a person such as a handprint, a fingerprint, or a retina scan. And in some cases, we combine these together to create multiple factors of authentication. So you might use a badge to be able to badge in, but then also include a personal identification number that someone would not have if they simply found your badge lying on the ground.
Nature's Bounty supplements your gut health with 20 billion live probiotic cultures. It's in your nature to thrive.
Ultra Rewards introduces the industry's most expansive global rewards marketplace featuring millions of unique products and experiences, all delivered seamlessly through a single powerful solution. With maximum choice and unmatched flexibility, it is designed to create a personalized, dynamic experience.
Many of us are very familiar with the process of authenticating. We put in a username, a password, sometimes there's an additional authentication factor, and that provides us access to a system. But behind the scenes, there is a lot more happening. So let's dive into the process of authentication. The process of authentication uses something called the AAA framework. We'll look at all three of the A's associated with the AAA framework in a moment. But first, we start with a piece of information that everyone has access to, and that would be the identification that we use when we're logging in. This is often our username, it might be an email address, but it's information that is usually available to pretty much everyone. This is public information. And just because someone happens to know our email address or happens to know our login name does not give them access to our systems. The first A in the AAA framework is authentication. This is the process where you prove that you are really who you say you are. This is often done with some type of private information, such as a password or some other type of authentication factor. Once you go through the authentication process and you prove that you are who you say you are, we now need to be sure that you're provided the access associated with that particular user. This is provided through the second A in the AAA framework, authorization. We need to be sure that you're provided the proper access to files, directories, or areas of the network based on who you say you are. And of course, we need to be sure that we track the people that are logging in and the people that are logging out. We do that through the third A in the AAA framework, or accounting. We want to be sure that we document when someone logs in, logs out. We also want to be sure that we document when someone does not complete the authentication process properly. There might also be other pieces of information associated with identification, authentication, or authorization that we might also store as part of this accounting process. There may be many different processes that occur behind the scenes when you provide your username and password. But let's look at a very common scenario where we're logging into a VPN concentrator from somewhere out on the internet from our laptop. We will need to send this VPN concentrator information about who we are. We need to provide a username, a password, or some other type of authentication factor. This is usually sent to a AAA server, which contains all of this username information, stored passwords in a protected form, and anything else that can help prove that we really are the person we say we are. If the information that we've provided matches what's contained on the AAA server, that server will send a message back saying that those credentials have been approved. At that point, we're able to traverse the network because we've gone through the entire authentication process and we were confirmed by this AAA server. On many networks, we only have to provide that authentication information one time during the day, and from that point forward, we can access all of the resources that would normally be accessible to us. We refer to that one-time process as a single sign-on. When we sit down at our desk in the morning, we provide our username, our password, any other authentication details required, and from that point forward for the rest of the day, we don't have to provide that information again. We obviously don't want to provide that access indefinitely, so there's usually a time frame associated with this, often 24 hours. So when we step back into the office the next morning, we will probably have to go through this process again. Single sign-on is a function that is directly associated with the authentication process, and not all authentication methods support single sign-on. So you want to check with the authentication method that you're using to see what options might be available for SSO or single sign-on. One very common protocol used during the authentication process is the remote authentication dial-in user service, or
We put it through the worst, so you get its best. Nissan, #1 in new vehicle quality.
Radius has been around for a very long time and is supported on many different operating systems and many different devices. And although it has the word dial-in in the name of the protocol, it is a protocol that can be used on our modern networks as well. So when someone is logging into their VPN concentrator, their concentrator may be communicating to the AAA server using the Radius protocol. This could also be used for other authentications, such as authenticating with a server or logging into your wireless network using 802.1x. And because Radius is so well supported across so many different operating systems, it's common to have this as an option on most authentication systems. So if you're installing a new VPN concentrator or new firewall, you may see Radius as one of the options available for authentication. Some authentication databases are effectively a list of usernames and passwords. And although that can be a useful way to store authentication details, it doesn't tell us anything about who that user might be or where they might be located. To provide additional context, we might want to use a more capable way to reference these details. For instance, we might want to use the Lightweight Directory Access Protocol, or LDAP. LDAP is a way to read and write information from a centralized directory on the network. This is very similar to a phone directory or a phone listing where you can search for users, you can look up different departments, and you can find information based on a phone number. LDAP is also a well-established standard. It was created by the International Telecommunications Union, or ITU, and it uses a standard known as X500. The original version of this protocol was known as the Directory Access Protocol, and a lightweight version of this protocol was created, and we put the L in the front to designate this as the lightweight version. So if you're using Windows Active Directory, you're logging into an Apple Open Directory system or a Novell eDirectory, then you're probably using the Lightweight Directory Access Protocol, or LDAP. I mentioned that LDAP allows us to add additional context to a particular user or particular device. We do this by using this standard known as X.500. X500 allows us to associate attributes to a user or to a device. For example, let's say that we have a web server. Obviously, this web server has a name. It may be called Widget Web, and by itself, we know that we can use that name to reference that web server. But it would be nice to have more context about where that server was located, who owns that server, and where that server might be maintained. So we might add additional attributes to that particular server's name. For example, we can add an organizational unit name. This particular organizational unit is marketing, which means this web server is managed by the marketing department. It may be part of a larger organization known as Widget. That organization may be located in London, and it may also be part of the widget.com network. Having this additional context allows us to understand where the server might be located, who manages the server, and where about that particular device. With these attributes, we can now start to build a hierarchy of information associated with that device and all of the other devices and users in our network. We can then build a tree containing these objects that we've built in our LDAP database. We might be dividing this particular database up by different countries. These different countries might have different departments within them, and ultimately you might have individual users or individual devices that will be part of that tree. We refer to these higher level objects as containers, and the individual users and devices would be leaf objects. This means during the authentication process, we can provide a lot of context about exactly who may be logging in and where they may be associated in the overall scheme of our organization. One open standard for authentication and authorization is known as SAML. This stands for the Security Assertion Markup Language. One of the goals of SAML was to make the authentication and authorization process open so that we can then apply it to many different types of applications. One of the challenges, though, with SAML was that it was not built for mobile devices. So if we need to authenticate to a device, we may need to do that across multiple devices if we need to use them all simultaneously. The authentication flow with SAML is a little bit different than the flows we've seen earlier. There's usually 3 different components associated with the authentication flow. There is a resource server, there's the client, which is usually you using a browser, and there is an authorization server.
All right, the last 10 minutes of class, we'll do 10 questions.
They don't already have authentication. That resource server will redirect that client to communicate to an authorization server to be able to gain access. Username and password information is then passed to the authorization server. It's confirmed through those processes we spoke of earlier through an LDAP database or Radius. And then if that information is successful, a token is generated and provided to the client. The client then proves that they've authenticated by presenting that token to the resource server. And the server will confirm that based on the cryptographic signatures and then provide an access granted information back to the client. And one of the last authentication protocols that we'll look at is known as TACACS. This is the Terminal Access Controller Access Control System. This is another authentication protocol that's been around for quite some time. It was originally used to control access to dial-up lines over modems at ARPANET.
The forecast, plenty of sunshine through today. We should reach our normal high. Cloudy and windy today with gusts up to 40 miles. Showers and thunderstorms today with strong southwesterly wind.
The Cherry Bag. Shop now at CoachOutlet.com. We can start whenever you're ready.
Ready?
Yeah. Wait, no, stop! Wrong pedal, wrong other pedal! There's no wheels here! What do you want? Stop the car! That's a kid! Kid!
Did I pass? Hello, the MVPs?
Hi there, mister. Oh no. How close did you come?
My life flashed before my eyes. I can't throw away my life in some dead-end job for crappy pay and no hope of happiness. No offense, Greg.
Oh, I wasn't offended until you said Greg.
Oh, sorry.
What do I like most about working here? The constant rush of superiority.
Group homes are non-valid peripherals. Did you realize your job is to ruin people's lives? This is mine now. It's out of ink anyway.
New guy. You started wearing makeup, stopped eating tuna. You staged the house. Don't blame me for checking out the Zillow.
Oh, hey.
You see what I see? The connection between them? With the menstrual pad stuck to her skirt.
How did that get there? It's a shame we could never, ever speak again.
What we do here makes a difference. I love working here.
Why? I mean, why?
I love every single person who works here for one big happy family.
We've got a job party. Hey, everyone.
Hey, what is going on in the... Oh, wow.
Oh, good. You made it.
They take away the free coffee, I'm out of here. I'm lying, I'm not going to.
I know.
Now 30 PBS, October 13.
You have no idea how hard it is to be a single woman in her 30s, okay?
Is it any harder than being a black man in his 60s?
I don't know. Is it? I mean, no. I'm so sorry.
The latest version of TACACS is known as TACACS Plus, and it's one that was very commonly associated with Cisco devices. And even today, people consider TACACS Plus to be a very Cisco-centric authentication method. However, many aspects of TACACS and TACACS Plus were made public and an open standard in 1993, and today anyone should be able to integrate TACACS Plus within their authentication system. It's very common during the authentication process to provide login details such as your username and your password. But of course, someone else could have access to that information, so very often we have other authentication factors that we need to provide. When we're adding additional factors to the authentication process, we refer to that as multi-factor authentication. This means we may need to provide a password, there might be a mobile app with a particular number that we need to provide, or we might be including GPS details that show that we're located within the corporate facility itself. Some popular multi-factor authentication factors might be something you know, that might be a password, something you have, that might be your mobile phone with the app that you're using. It might be something you are, such as a biometric reading, for example, your fingerprint, or it might be somewhere you are, which would certainly be a GPS location. One or more of those could be used during the authentication process to help prove that you are really who you say you are. The factor of something you have is often associated with a TOTP. This would be a time-based, one-time password algorithm that is integrated into an app that you might have on your mobile device. This usually has a secret key associated with it, and it uses the time of day to be able to provide what is considered to be a pseudo-random type of numbering system. This number tends to change occasionally, so every 30 seconds, you may get another randomized number that appears on the screen. In reality, this is not a randomized number. It's a number that only seems to be random, and it's a number that is expected by both sides of the authentication process. This is accomplished by creating a secret key ahead of time and then synchronizing both the client and the server using a protocol such as the network time protocol. So during the authentication process, you may be asked for your username, your password, and then the code that appears in the app on your mobile phone. This is becoming a very common way to authenticate, and it's one that's used by Google, Facebook, Microsoft, and many other organizations to add additional factors to the authentication process.
At King Soopers, you never compromise. You get up high quality that's guaranteed fresh and down low prices on over 1,000 items. With quality and savings that add up, King Soopers shoppers never compromise. King Soopers, fresh for everyone.
Compliments of the chef.
Oh?
He was so glad that he had emergency roadside service with Geico. And since they saved his bacon, he presents to you a bacon tart flambe.
Well, thank mate. Look, I don't need special treatment. I'm just happy that he's happy.
You're too humble, Mr. Gecko, which is why we also present to you, and I don't need special treatment, run-of-the-mill blue cheese.
Oh, now we're talking.
Yes, we are.
Get more savings in service. Get more with Geico.
In IT security, there is a constant fight happening between the attackers and the folks that are being attacked. And one of the ways that we can learn more about our attackers is to watch the attacks themselves. One of the ways that we can do this is through the use of a honeypot. We know that these attacks are often not a human being who's typing into a keyboard interactively. Usually these are scripts or programs that are designed to attack many different systems simultaneously. So one of the things we could do is to create a virtual network with virtual servers and virtual components that would be very attractive to one of these attackers. We're effectively leaving out this virtual honey that hopefully will attract this attacker's sweet tooth. If you want to see what people are using as a honeypot, or you'd like to build your own, there are many open source versions available that you can install on your own systems. The attackers, though, are very good at determining what might be real and what might be fake. So there's a constant battle to build the best possible honeypot so that you can attract the attackers and be able to watch what they're doing during. To make this attractive to the attacker, we need more than simply a single server or a single device. We need a number of different components. We need servers, workstations, routers, firewalls, switches, proxy servers, and anything else that can make this system seem a little more real. When we compile all of these together, we've now created a honey net. We now have a much larger deception framework. We might have the attackers start with a workstation as part of the honey net, then they would move to a honey net server, and then we might see if we can move them over to the honey net NAS. These are commonly virtual devices, and we can build any number of these to be able to attract the attackers. If you want to read more about honeypots and honey nets, there's a wealth of information on the internet, and a good place to start would be projecthoneypot.org. In the world of IT security, a lot of the decisions that we make are based on risk. Risk is the exposure that we have to something that might be harmful or something that might be dangerous. If we need to describe how possible it might be for something bad to happen, then we would be describing risk. Risk is a constant concern for every organization, and the larger the organization grows, the more risk they tend to take on. We would always want to consider how risky a situation might be during the process of expanding, adding new applications, making changes to a configuration, or anything else in our organization that might open us up for attack. Whenever we're making business decisions on what we do next, we always have a level of risk associated with that. And it's important to be able to identify what that risk happens to be so that we can then make a business decision on whether we continue with that particular task or whether we add additional security controls to help protect that task. If you've been reading through your monthly Microsoft patch notes, then you've probably seen a list of vulnerabilities that have been identified by Microsoft. These vulnerabilities are listing a set of weaknesses that are associated with the current version of the operating system. And if someone was to take advantage of those vulnerabilities, they could potentially gain access.
All right. This is what we got. Getting toward the end of the day. We didn't even get the skills learned today, did we? For last week. We'll get to it in the morning first thing. Okay. So this is my Linux Plus Cert Master for CompTIA. This is what you're talking about, Martin. The other instructor probably had the same thing, look like this. Cert Master. So with these questions, they may ask you some Linux commands. So we'll just do the quick 10-question review, lesson review for using Linux basics. And we'll see what it throws at us for the lesson review. How about that? All right, so here we go. Try your best shot.
The breach itself is described as an exploit. This is when someone takes advantage of the vulnerability to gain access to a system or gain access to data. Usually, the exploit is taking advantage of that vulnerability, and there may be many different ways to accomplish this. This might be a relatively straightforward exploit where
Risha has just rebooted the system after reinstalling an application as part of her solution implementation. As she logs in, she identifies that the application will still not start correctly. What should she do to attempt to best resolve the issue? A, B, C, or D?
But threats in our local area are things that we often understand.
Michael jumps in and already says,
Threats to our systems are coming from somewhere outside of our organization. So if your operating system has a vulnerability,
he says uninstall the application and reinstall it.
Agent that takes advantage of that vulnerability by creating a threat action. This threat action will exploit the vulnerability and allow the attacker to gain access to the system.
Okay, oh dang, a whole bunch of them roll in. I turned my face for a minute. I see C, B, B, B. All right.
Where they may gain access to
I see some B's.
or perhaps make that information available to others on
Identify a new probable cause.
To combat these attacks, we rely
Yeah, it's already
all right. Looks
restarted
like the
and
B's
reinstalled.
have it, so we're just gonna click B just to see. And I want to no, I don't. Check my answer. And bam, you will be correct on that. The question already said.
Yeah, it already says that.
She has just rebooted the system after reinstalling.
Yeah.
So it still won't boot, even after she did that.
Yeah, that
so,
would have been redundant.
Probable.
confidential.
Yeah, I saw that, and I wanted to say B as well, but the thing is, sometimes programs, they suck, and when you reinstall, yeah, it works.
Integrity
Yeah.
means that the data that we are
But remember the
referencing has not
CompTIA
been
way.
modified by any third-party means.
CompTIA,
For
yep,
example,
that's what gets us.
messages
'Cause
Yeah.
you know what got me, Michael? I used to think
Yeah.
the same way. This is what I would do. Because we have hands-on, right?
Yeah. Yeah.
But CompTIA's like, no, you've tried that already. What's the next step? Yeah, that's how they get us. Good job, y'all.
IT security, but information technology.
Here's the next one. Here we go.
Is availability. We want to be sure.
Which of the following is the standard shelf for most Linux computers?
Or most.
And for most
Or
people in information
for
technology, we
Linux,
understand that the
it's
importance
Bash.
of maintaining these systems and security involves making sure that they are available to anyone who needs access.
I'm seeing D a lot. Charles says I want it to be B. You've seen that somewhere before, haven't you?
Yeah, I'm gonna say Bash. Bash, yeah.
There is a corn shell, but what's the question? The question says though, is it the most?
Yeah, it's the.
Is it the standard shell for most?
Yeah, it's asking for the
Linux
most.
computers. What's the standard one for most Linux computers?
Yeah, I would say Bash.
Your investments means asking the questions others don't. Activate managed ETFs from T.
Yeah.
I'm gonna give a chance for Charles to answer it. He's really looking at it.
Oh, Charles. Oh, okay.
You good?
An ongoing challenge for IT
right.
professionals is to make
That's what we're gonna. Looks like that's the majority right there.
policies, procedures,
And you will be correct. It is
Bash.
the born again shell.
type of work.
I was hoping nobody picked born shell. Because if you read it too fast, you would have picked it.
Yeah.
You thought the same thing.
Yeah, yeah.
Yep. If you read the question too fast,
Yeah.
there is a seashell and a corn shell. Corn is for ooh, don't give me that line.
Corn.
Think of Red Hat or Sussy. Right, Mr. T? Is it one? I think it's Red Hat. Yeah. All right.
But it's not a standard one that they
Next.
use.
Good job, y'all.
In many geographic areas,
3.
one type of compliance is associated.
You are currently in the home directory /home directory and need to view a file named test file 1.
An example of this can be found in the GDPR. This is the
.text from the bin binary directory. Which of the following commands would allow you to view the file one page at a time with both forward and backward navigation? Dang. Listen, I don't know. Shoot, you got me. You said forwards and backwards.
I want to say read. Yeah. Yeah.
All right. Charles said, what?
Yeah.
This is the funnest part of my day when y'all do this. Okay. D. What Jesus put? What Kevin put D? Where B Weezy at? B Weezy put D. All right, everybody's put D.
Email address, bank information,
Let's go with that.
websites they visit, and any other type of data that user may
Less.
What the?
Less command.
European Union citizens must be stored in the European Union. The user
Oh, yep, right there. Would allow you to view a file one page at a time.
The GDPR is designed to give
So when you do read, you're gonna get flooded with everything. Yeah, you're gonna get everything. More is the one where you could say you only want so many things per, and you have to keep hitting the return, and it'll show you more and more and more.
Yeah.
Head will show you the first 10 lines, head of the first 10, right, of whatever's important. Yeah. Okay.
Okay.
So it's less.
Less than that one.
credit card information. There are 6
Less is more.
areas of focus associated with
All right, let's do another one. Here we go.
We need to
All right.
build and maintain secure networks and systems. This is something that will help protect.
You have forgotten what information is provided by the Who Am I command, and simply want a short description of the command. Which of the following commands would you enter to view the short description?
Yeah.
Somebody put C. Help, who am I?
We need to implement
Elaine put C. Michael put C. With a question mark.
gain access to this credit card data. There needs to be
A?
Leah put A. Who am I?
Oh.
Help.
Ensure that all of the policies that we put in place are indeed working as expected, And we need
Jesus put A, Martin put A.
policy so that we have a broad.
So what's the majority on one point? Let's see by at least one.
Data within our organization.
Yeah, I want Will. Here we go. Reveal.
To see if they're following the
I think it's man. Boom. Man.
And an organization that's not following these policies could result in.
So this is the way man works. You type in man, manual, and then you man, Charles.
Yeah.
Man, who am I? You're an IT technician. That's who I am. So man says go to this manual page, and then you put the command, and it'll bring up everything about that command.
Okay.
Yeah.
Okay.
Now help. Aaliyah says I thought man was a detail longer.
But
now you could do man, and it'll bring up the whole manual on Kali or Linux. If you do help, you have to do who am I dash help or who am I space / question mark. Yeah, for the brief description. I was so close. Okay, one more. Looks like we got time for one more. I like talking about this stuff though, so you can see what it looks like. Here we go.
From a security perspective,
which of the following commands should a Linux user enter to see a list of all the commands the user recently ran at the command prompt? Ooh.
Sometimes this segmentation has already been determined.
You name clear.
Interesting.
I'm good.
Jesus put C. CHSH.
Our industry is dealing with a large number of new devices connecting to the network that are IoT devices or Internet of Things.
Which y'all's that? Elaine says C, but he's definitely saying D. I like the way you put that. C question mark, but I'm saying D. Maybe C he doesn't know.
Yeah.
I don't remember going over CHSH.
Yeah.
Charles says, I want to pick history, but I have a feeling it's C.
Yeah.
So far it's C.
Yeah.
Everybody's picking C.
Yeah.
All right. Y'all want to play follow the leader. Here we go.
All right, let's go.
I think it's D.
And away from your data might be a good choice for IT security. Industrial devices.
Yeah.
That's simple. Oh, wait a minute. That comes in a quick second to Charles' activities. He's pissed.
Yeah.
Oh my gosh, y'all make a long day.
Yeah.
Crazy.
Yeah, it's true.
All right, okay, the old trickery. All right, before we get out of here, is there anything I can do for y'all today? For the rest of the day?
Man.
Yeah, you guys got it. Y'all were really flooded today. You had a busy schedule. So tomorrow, we hit day 12. We only got 2 more lessons. Then we hit review. Okay. During the review time, then we'll walk through some labs, some 101 labs, because we'll have like 2 days. I'm trying to get ahead with lecture.
Yeah.
So the last 2 days, we can walk through some stuff. All right. So if I go on a tangent with just teaching straight through, just bear with me. Because that'll leave us 2 days where we can just ask questions,
reviews,
make sure the final's done, go through some examples. That sound good?
Yeah.
And just talk and study. All right. If you don't have anything, tomorrow I'm staying after for an hour. We're staying after for an hour. So if you want to join me, make plans for tomorrow. All right. And skippy hip and carry out the command. Boom.
If you look at a network with SCADA devices, you'll notice that it is completely segmented from the rest of the network. And only people with the right access in the right location are able to access these systems. Uptime and availability becomes even more important when you talk about operational technology, or OT. This could be systems that are designed to keep the electric grid up and running. It might be for traffic control, or it may be an entire